It is 9:01. We will call our workshop to order. Oh, there it is.
Call around on the ground. Thank you.
We will, all five commissioners are present. We'll go around the room and do introductions here real quick. Starting with Brandon.
Brandon Warburton, Port of Morrow.
Mark that, Port of Morrow.
Lisa Miller, Port of Morrow. Alex Hendricks, Port of Morrow.
Craig Reader, Madison Ranges.
Joe Metzel, Parametrics.
Lauren Grizzly, Parametrics.
Jackson Iron, Port Morrow. Jacob Kane, Port Morrow.
Vern Frederickson. Dick Madison, Madison Ranges. Port of Morrow.
Okay, and online,
Okay, we'll start with Brian Jackson. Brian, we cannot hear you or see you, just in case. I saw you on mute, but we didn't hear you or see you. Still can't hear you. Just so you know.
oh,
We'll move on. Frederick.
Yes. Good morning, everyone. My name is Frederick Tack. I'm the National Technical Practice Leader with Consor Engineers and serve as the project director with Consor on the secondary treatment project.
Austin.
Good morning, everyone. Austin Rampin with Consor, and I am the engineer of record for the secondary treatment project.
Thank you. Debbie.
Debbie Rady, Boardman Foods.
Justin.
Justin Sturger, Oregon DEQ.
Kayla.
Kayla Boylan, Lamb Weston.
Erica.
Erica Morton, Port of Morrow.
David.
Good morning, David Albrecht, Special Districts Association, Oregon.
Jamie.
Jamie Stewart, Tillamook.
And ORA.
Good morning, Kristen Ostrom with Oregon Rural Action.
okay. Thank you very much. Okay, so what we'll do, we're gonna start with Consor's presentation here, and then we'll move on to Madison Ranches. Anything else that I need to add? Staff-wise, anything different?
No.
Okay. Well, we'll turn it over to Consor.
All right, thank you. Let me share my screen here. All right, can everybody see that?
No.
All right, let's get going. We're here to give a presentation update on the secondary treatment project. For the agenda today, welcome and introductions. We just had a group introduction, so great. We're going to give a recap on the project goals and purpose, value engineering, where we ended up there, give a design update, and then go over the next steps and schedule. So we already covered the introductions for everyone. Welcome again. To get into the purpose and goals of the project, the main overarching goal is to meet the new permit limits mandated from DEQ for the port's water pollution control facility permit. Reducing the nitrogen loading in the irrigation water is the ultimate goal, with some other goals to provide operational efficiency, optimization, and strategic redundancy, with the ultimate goal of being complete with construction by July of 2029. So some of the drivers for this project, obviously there are several, but regulation is a big one, environmental protection, and then minimizing impacts to the port's customers. So ultimately, the effluent design criteria we are targeting is a maximum concentration for BOD and TSS of 20 milligrams per liter, 7 milligrams per liter for total nitrogen, and then having the effluent be in a range of 6 to 9 on the pH scale. So now to dive into the value engineering early efforts, I'm going to hand it over to Frederick.
Yeah, thank you for that, Austin. So, really the recapping on the timeline of the project. So, design was started in 2021, 2022. Final design was completed in 2024, and the project was bid. In the summer of 2024, those results identified the overrun of the project budget and the project cost. So early last summer, we did some initial quick value engineering cost savings, following both regulatory and industry best practices for approaches for some value engineering savings. There were 6 initial alternatives considered, different technology, different configuration, different materials, a variety of different approaches. And looking across each of those, at best, we found about a potential for about 16% savings on that cost. As you can see highlighted across the bar there on the bottom. And note that the contractor bid, there's more than just the cost of the contractor bid. There's the cost to manage the project, deliver the project, oversee it to make sure it meets performance and quality requirements, and to also ultimately close out and commission that project. So the the cost of the contractor bid showed in that first line, plus the additional cost for changes, improvements, and managing the project result in that total cost. Austin, yep. So we can see there the initial bid lowest responsive bid came in just over $178 million. The total cost to deliver that would have been $192 million. And with that savings of a potential of 16%, potentially could get that down to $161 million. So continuing on that, Austin, next slide. We focused on what the best value-added value engineering approaches were, and also discussed those with DEQ prior to proceeding with any of those changes. So we workshop with the contractor and those bidders to provide the best input to manage cost during construction. Also reviewed approaches with DEQ for regulatory approval. So one of the main approaches was to reduce the peak flow and loading to the plant. So the more capacity, the more flexibility and range the plant needs, the more physical infrastructure that's needed. So the best way to cut down on the highest cost of the project, which is the physical infrastructure, is to reduce that peak load and flowing flow and loading. So that approach would manage peak flow conditions in the existing infrastructure, so the existing anaerobic digesters. Another key value engineering item was omitting the denitrification filter. Denitrification can still happen, and we can still meet the regulatory goals in the oxidation ditches, which is the main secondary treatment process. The denitrification filters were really a polishing step and kind of belt and suspenders. So we identified the ability to remove that from the project. There was some opportunities to simplify the influent flow diversion, how things connect, rather than building structures, keeping it in pipes and keeping it underground. We also evaluated minimizing the standby power generation, as the cost of standby power generation is very high. We revisited lower cost items, but where there's a lot more of it. Electrical distribution wiring, lighting, and materials for such features. And then also changed the technical specifications to allow for more competitive process across some of the manufacturers, specifically with the instrumentation, which is a multi-million-dollar package for the facility. And we're able to find millions of dollars, at least $1 million of savings there. Additionally, we reviewed some different materials, processes that could still meet the durability requirements, but that might be able to return cost savings. Austin, next slide. So I want to talk about some of those just to understand what this means. So first we talked about attenuating the peak flow or managing those peak flow and loading in others. So using the existing anaerobic digesters allows us to reduce the overall capacity of the plant. And it also allows for construction of additional trains or processes in the future. So we still have the space planning for the ability to expand if needed, but reducing the peak management of those peak flows, and therefore reducing the cost. Austin, next slide. So here in this picture, you see an image. These items, these are the oxidation ditches. This is the main secondary treatment process where 3 trains were initially planned and designed, where 2 trains were defined as duty and the third as standby, but also that could manage the peak flow conditions. By removing that peak flow requirement, we were able to remove one of those oxidation ditches. Therefore, we could manage the average flow in any one of the 2 remaining ditches at any time, and change the approach to that train so that each train has that ability to flex and still handle some peaking condition, just not the overall infrastructure that's required for the third. Next slide, Austin. After secondary treatment, we have secondary clarification, which is a final polishing step in this tertiary treatment. Originally, the plan was to have 4 secondary clarifiers with room for a 5th. Therefore, all 3 clarifiers could be in service and 1 out of service. Being able to remove that peak flow condition was able to remove the 4th clarifier and then change the approach to the remaining 3 secondary clarifiers. As you'll see, the theme here, by reducing the infrastructure, we reduced the amount of physical infrastructure and equipment at the oxidation ditches by 1/3. By reducing one of these secondary clarifiers, that reduced that infrastructure by 1/4. Next slide, Austin. Other considerations, again, not just for the peak flow conditions, but optimizing how these systems were used. There's chemicals that are used in this process. Alkalinity is used to manage the overall treatment process, and nitrification and denitrification by reducing one of these silos, which holds lime for this process of adding alkalinity. Again, cuts that cost of that facility in half, and therefore we're also able to reduce the mechanical systems, so the carbon feed systems that would feed that into the treatment process. So a systematic approach of understanding of an overall value engineering concept, and then kind of weaving our way through the design and identifying what features can be omitted and or optimized and able to meet the overall performance requirements. Next slide. The denitrification filter, again, this was a feature to help with denitrification. We were able to revisit partially by removing the peak flow conditions, but also reevaluating the oxidation ditches, able to remove that tertiary filter. This is a large piece of hardened infrastructure, very big concrete filters with media, and a lot of large piping to that as well. Being able to remove that doesn't completely remove the cost around that, as that infrastructure was combined with a plant pump station and a clear well that needed to be redesigned. But again, could still, we were able to go back and verify through our own process modeling and calculations and get warranty from the equipment manufacturers that we can still meet our performance and our nitrogen limits without the denitrifying filter. Some of the small parts and pieces that really do result in large savings, such as this influent diversion. I talked about changing some infrastructure from kind of being hardened concrete above ground to keeping this infrastructure below ground, again, with good input from the port and their staff and the contractor as well. We were able to take this structure and change it into just a below ground valving system, again, still providing the value and performance that's needed without the high cost of the infrastructure for that. This still provides the full ability, and we were able to actually even improve the ability to bypass and manage flow with this system. Austin, would you maybe like to review this and continue?
Sure. Thanks, Frederick. So some other alternatives we looked at, we already mentioned the first one, the corrosion control system for the influent flow split. We'll get into a little more detail on that with a design update. But basically, the effluent from the anaerobic digesters has high levels of hydrogen sulfide, which will over time deteriorate the flow split structure, concrete, and any metal that's in there. So we looked at adding an active odor control to that flow split structure, basically to extend its life. And Chad and team are scheduling an upcoming ozone pilot to test out some technology so we can make sure the design is dialed in. Other items we looked at were using precast vaults for various structures, one being the plant drain pump station. It was actually too large to pencil out. It's actually cheaper to make it cast in place. So we checked that box. We looked at some material changes, including the process piping materials and various building materials. For the site work, we revisited the site-wide gravel and stabilization. We had about 10 acres of gravel going into the site, and looking at that, it was decided that we would just provide gravel stabilization for the access drive lanes. We also looked at revising the lighting layout and the products, mainly the light poles, in coordination with the contractor on what was coming in cheaper cost-wise, and also maintenance considerations for the port staff. And as previously mentioned, we took a look at the standby emergency power requirements and decided to back up the controls only and not the entire plant. So giant generators have gotten omitted from the project, and we're going with a couple smaller ones. And also previously mentioned is the unit process instrumentation, changing from Hawk to YSI, which is the vendor's preferred brand, brought us a lot of savings. So now I'll give it back over to you, Frederick, for the design update.
Thanks, Austin. If you could just advance to the next slide. So an overview of what we discussed on those value engineering changes. So all those things that were considered were then pushed into design. So we coordinated with the port team and started those redesign efforts in mid-fall of last year after qualifying the value of that savings and coordinating and discussing that with DEQ as well. So the items in the kind of peach or pink color there are key items that were removed. We discussed there that of removing one of the oxidation ditches, significant savings there. One of the secondary clarifiers, the denitrification filter, one of the standby power generators, and then one of the chemical feed systems. Up at the top right, we show that color also over the flow diversion structure. That was really just changed to a below ground feature. But we also added and improved some items. So one of the items that we were able to improve was the oxidation ditch flow split. So that's the main point where flow is diverted to these oxidation ditches. That's where the most corrosive atmosphere is, right, where a lot of the corrosive materials are released from solution. And that's where we identified the need to improve the durability and life cycle of that. This is a key piece of infrastructure that needs to last. And initially was taken just to have a passive condition where that odor would be released. We identified and qualified the value to enclose that and add active odor control, therefore mitigating and reducing that corrosive environment and extending the life cycle of that infrastructure. The other item in blue there, which we'll talk about here briefly, we identified the opportunity and the need to improve this building. This is called the WAS-RAS building. So this is where we pump the wastewater material that gets recycled inside the plant to keep biology properly moving around in the plant, and then also wasting microbiology from the plant as well. This was a pump station that was planned as a vault, so below grade, had some long-term higher cost to operate and maintain, and some limitations on the ease of operability and really influencing a higher cost of operations. Austin, next slide. So first with that influent splitter box. This is just a model, a snippet from the model of the update to this. In short, we're putting a top on this box to simplify it, and we're adding some piping to withdraw the odorous air from that we will actively treat. As Austin mentioned, we're currently coordinating a pilot where we're testing some ozone equipment where we use ozone to knock down and mitigate that high corrosive atmosphere. Otherwise, we have two other technology alternatives, and that will really extend the life cycle of this process well beyond the initial design. Next slide. So this is that building I mentioned, the WAS-RAS pump station. Again, this is a snippet from the model of what's currently planned for design. Originally, this vault or this feature had a top on it. Basically, where the floor is at that mezzanine level was just a top where operators would open a hatch and climb down a ladder to get in there to operate. And then there'd also be hatches for lifting pumps and motors out of there. By actually turning this into a building, we're able to make a safer environment. And we're also able to reduce the long-term cost to operate by providing better access to these features and reducing the overall construction cost or the overall construction schedule for this as well, and simplifying the method of construction. Most of the buildings proposed on this site are tilt-up concrete. This building is being planned with having a brick and mortar walls with a truss roof as well. That will improve the overall construction schedule, but it does mix some of the construction materials as well. Next slide. Austin, you want to talk about next steps and schedule?
Sure thing. So here we have our timeline. I'll just kind of walk everyone through where we've been and where we're going. So in 2018 to 2022 was initial planning. Consor got on board in late 2022 and worked on the design. We finished the design in March 2024 and went out to bid. Open bids in June 2024, and the low bidder was $178 million. And this meant that the project was over budget, and we had to rethink elements and go into the value engineering phase. So we had several workshops with DEQ, the low bid contractor, and port staff. We went through the alternatives analysis, like we briefly mentioned earlier. And this study is required for state-funded treatment plant projects that are over $10 million. So it's a requirement from the SRF program. So now we're about 85% through the redesign effort. The technical specifications and sub-discipline designs are remaining. A little bit of work left to do on those. We're targeting completion next month for submission to DEQ for permitting, review, and approval in the April-May timeframe, and then negotiate, rebid in the May and June timeframe. So looking ahead, we are finalizing our redesign efforts now. We'll be submitting for regulatory review soon. DEQ already has the updated basis of design report and is ready to hop on this review once we get the package submitted. We're in the process of finalizing the VE study and coming up with the savings potential. We're also compiling updated quantities to help with the port's renegotiation with the low bidder. And the next steps after that is to secure the project funding, continue negotiations, complete the redesign, regulatory approval, get through the loan documents, get the contractor's notice of award, start construction, and then finish construction in summer 2029 with commissioning in July 2029.
Thank you for that, Austin. The what I wanted to mention about the potential savings that we identified. So through that value engineering effort, it's written as, and Austin mentioned, it's the potential range of savings. We are doing our duty to identify updated quantities and what our anticipated savings is, but until the quote or proposals come back from contractor or contractors on what those changing costs are, that's to be determined. The percentage of infrastructure that we've saved is between about 18 to 23% through these efforts. That doesn't exactly equate to an exactly 18 to 23% savings, but it right now at that range is between 25 to $38 million as we project. That's not a solid cost back from manufacturers and bidders. So the effort that it took to find and deliver those savings in redesign is approximately about $1 million to save 38, potentially 38 plus million dollars. And that's what we project at this time. So with that, I'd glad to turn it back to the commission.
Any questions for going forward? One question that came up was on just the backup power. It's reduced. Does the rest of the plant continue to run without power?
Yeah, great question. I'll start here and I'll let Austin and or Mark or others comment on our approach to our change in the backup power is that the plant will be continually able to monitor and measure the process and the operations during this condition, and that the major process components will maintain power. However, during a major power outage, the lift stations that feed this plant may not be operable. So the balance of needing to operate this plant at full capacity during such a power outage, that assumption was limited to always being able to monitor and measure what's going on at the plant, and then reducing the power to just the main process control systems during that power outage. Austin or others, anything you'd like to change or correct on that answer? No. Okay.
I would just add that the biggest component there is attenuating flow. So if we have a power outage situation, normally that duration is short. We have enough storage and digesters and temporary future pond storage to attenuate flow instead of continue to operate the plant, right? So it'd just be a bypass until the plant's operational. Turn it back on. Any type of long-term power outage situation, which I think I haven't seen one in the last 10 years. I think the longest power outage we've seen was 6 years ago, and it was a 6-hour or 8-hour outage. Clients would have to start to shut down at that time. So it's not an immediate need. We see a long-term outage, we get feedback from the utility supplier saying this is going to be long-term, then we're going to have to go back and start shutting down our input.
Power outage would affect the clients too, wouldn't it, generally speaking? Yeah.
It's a whole ball of wax, right? Water supply, it's a cascading event that this plant wouldn't need to operate a long-term situation.
So what's the cost savings is there a breakdown of those? We couldn't see that. I couldn't tell if there was if we have a good backup power source, or what's the cost? What are we giving up?
I don't have the exact number, but it was in the magnitude of $5 million to remove that generator.
And that would be for the lift pumps.
That was for the generators.
The generators for the lift pumps to get the facility run.
The major energy consumer in the process is blowers. So oxidation ditches are oxygenating the water. So we've got 3 600 horsepower blowers putting air in the system. So that's 8. That's our biggest energy consumption is the blowers.
And Jacob, if I could, I was going to say our approach to remove some of the hardened in place standby power generators in order for that to work, there's what's called an automatic transfer switch. So when the power goes off, that switch transfers power from the AC current to the standby power generator. In place, what we would have is a manual transfer switch. So instead of spending the $5 million to have the number of standby power generators on site, you would have the ability to plug in a portable or a temporary generator if there was an extended power outage to be able to provide that power.
The moving peak flow feature, I think, was that the right terminology was used? I guess I'm just trying to understand what that means, removing peak flow.
I had that question too.
Yeah, so let me just use an example, and I don't have it specifically for the plant. Austin, feel free to jump in here if you have. Let's say the average flow is 10 million gallons per day. Um, and then the peak flow could be 3 times that, right? Or it could be 2 times that. So 20 million or 30 million gallons at a time. So providing the capacity, both in performance of the loading and the actual just to move that amount of flow, needs more infrastructure. We need, basically a wider channel. We need more infrastructure to move that flow. So there is existing capacity in the upstream anaerobic digesters to operate those at a deeper depth. So coordination and direction from the port of choosing to manage that peak flow in the existing infrastructure. Therefore, we just are anticipating or designed around having that 10 million gallons per day coming at the plant. That's what helps scale back some of that infrastructure. So flow to a wastewater treatment plant is diurnal, so it's at different amounts at different times in the day. So the approach to this wastewater treatment plant is we're really providing the average capacity to treat. So when there's peak flow conditions, it's more than the average. It's going to be stored in those upstream existing anaerobic digesters or lined impoundments. And then at times when it's less than average, they will then send that flow down to the plant. So it adds another step of operational control to manage that flow, but it greatly reduces the capacity requirements for the plant. Does that help at all?
Yeah, it does. I understand. So that would be a change though. We would have to plan for that in the digester operation. We wouldn't be able to necessarily operate it or store at 80%, it's stored at what, less to manage the flow if we have incoming flow?
Well, it's a little bit more complex than that. So the original design, the peak flow is 27 MGD through 3 trains, right? So that is a huge flow.
So, million gallons a day.
Yes.
Okay.
Yes. So under the current design, we can push 9 MGD through a single train. That's 18 MGD total, which is abundantly more than what we currently see, right? We can push 9 MGD through a single train. So under maintenance, there will be maintenance windows. We got to take a train offline. So we can push 9 MGD through a single train while 1 train is down. So when both trains are operational, which is normal operating, protocol, a maintenance window will be a scheduled long-term event. So we can average, we can push 13 MGD average daily through it today, which is more than our average daily flow that we see currently, and push up to 18 MGD through both trains. So using the digesters is an extreme event that wouldn't be normal operations.
How long can your with maintenance be?
It depends on what system is down, right? But in general, Jack can answer this too, but just to get so say you take the water, say you drain a train, it's gonna take a pretty significant amount of time running the train a day, 2 days. You do your maintenance activities, is that a week? And then to get the biology back happy, back when we're refilling, it's gonna be another week. So you're probably talking about a 2 to 3 week period.
On average, say normal operating conditions, how much additional capacity is what is being proposed today and provided to the, as far as growth?
What's our average flow right now? Yeah.
6.5 to 8 million gallons a day.
So we have 6.5 million gallons there, and we're gonna be able to push it to.
What's the solids load that's gonna come out of this?
Is everything online here then, okay? I know you guys are in the back of the room. Frederick, are you able to hear Jacob? Jake?
I didn't quite hear that. I believe I heard how much solids is produced out of the process.
Back in the room, will you guys speak up a little bit? Sorry.
Yeah, it's okay. Austin, could you speak to that? The capacity we're providing, say, in the dewatering system overall?
Yeah, so as far as removing the waste activated solids from the clarifiers as part of the process, the dewatering design includes 4 screw presses and a conveyance system to make that into a dewatered cake, anywhere from 17 to 20% solids. And so that would be stored. There's a big cake storage area, and then be discharged into dumpsters or moved around with equipment. And I don't have the numbers right off the top of my head, but at startup, it will be a couple of trucks a day, couple of big dumpsters a day of solids that'll need to be taken care of or disposed of. And I believe Chad's been running the numbers on kind of build out and where we're going to get with solids production once the facility sees future flows. But we're talking a decent amount of solids that are going to need to be reused or given away to farmers or sold, somehow monetized. But yeah, that is a big component of this project is how do we get rid of those waste residuals? Did that answer your question?
So is a big truck like a 10-yard dump truck or a semi truck?
Probably 10 to 30 tons per day. That number fluctuates. Startup, their starts are going to be any, and then by the time it gets operational, average daily flows quite significantly less than 30 MD, but it's 20 to 30 tons per day.
So has anybody had a discussion with DEQ on whether that would require another permit for land application or anything?
Austin, could you respond to that?
What was the question?
Has anybody had any conversations about the need for an additional DEQ permit to handle the solids?
Oh, yes. No, there's not any requirement from DEQ on the food processing residual solids. If this was a municipal plant and they were called biosolids, then there would be a lot of regulations, and you'd have to come up with a biosolids management plan, get that approved by DEQ for the end use of those solids. But because this is industrial and it's food residual processing solids, that there's no mandate or guidelines or permit needed from DEQ for that.
What's the value of these solids then, if they come out? Is there a value to someone?
Do you want to go?
Well, just needs to know, there might be, I don't know. Yeah, a refuse that needs to be disposed of, is it something that's of value to somebody?
It costs money to apply, they're expensive to handle.
That's a lot of water, if you're talking 17 to 20% solid, that's a lot of water.
So to clarify, when the solids are removed from the water, they're safe food waste. But when they're in the water, it's industrial waste. Can you explain to me?
No, that was the difference between municipal sewage and industrial sewage, if you will. DEQ clarifies the municipal biosolids as they need a program. They need to know where their end use, their land application, their landfill, are they giving them to farmers? They track that heavily due to the pathogens that are potentially present in those biosolids. With food processing residuals, they do not fall under that same category in DEQ's mind. They do not have the vector attraction issues that some biosolids have, and we see these as being probably likely easy to get rid of. We're not sure about monetizing them. It'll just be based on the connections and the networking that the port has with farmers. And they're going to be, rich in nutrients, great for fertilizer. Obviously, we're trying to keep nitrogen out of the groundwater in the area around the port. So that creates its own challenges. But
But in your discussion, you found that the DEQ finds that those solids is a fertility source. Is that what you just said?
yes.
Why are they being, do they need to be removed? Why are they being removed? Does the DEQ want the solids removed?
For the process, they need to be removed to meet the permit.
Yeah, can I maybe ask a clarifying question here? So Austin, I think maybe what Craig, and feel free to correct me if I'm not hitting the question here, but you distinguish between food solids and let's say municipal solids.
Mm-hmm.
But one of the key drivers of the entire project is the nitrogen in the wastewater and removing nitrogen so that it can be land applied and protect groundwater. But what you're saying at the end of the life cycle of this treatment system, you will now be left with a solid waste that presumably still has very, as you said, very nutrient rich, so a lot of nitrogen. And the solution is then to go land apply that somewhere. And so I think the question is, why are we removing it all on the front end if we just have to convert it to a solid and then go land apply it on the back end? Have we looked at, you said it'll be easy to dispose of, but have we looked at how much biosolids will we produce? And can it be land applied on the amount of farmland that's currently available in a manner that DEQ will approve and say that the port is in compliance?
Yeah, if I could speak to that for jump in here for a second. Thank you. Yeah, good question. So part of this process, this industrial wastewater secondary process, we are going to be reducing the nitrogen concentration. So we're using a biological process to nitrify and then denitrify. So we're actually converting the ammonia to nitrate to nitrite and then releasing the majority of it as nitrogen gas. So that the liquid effluent that's produced from this process, it has lower than the total nitrogen limit. So under 10 milligrams per liter, and we're targeting about 7 milligrams per liter or less. The solids that are removed from this process, sorry, I almost said biosolids. The solids that are removed from the process are not as nitrogen rich. So it's not that the nitrogen is being taken from this overall stream and then deposited or precipitated in the solids. The solids most likely will have less nitrogen than the liquid stream does. But again, they are a concentration of that process. So that nitrogen is actually the overall nitrogen is being reduced and the majority is being released as nitrogen gas. So those solids will not have high nitrogen. They won't be like, of a very high quality fertilizer type, high in phosphorus or nitrogen. This process does not remove any phosphorus generally from the system. So any of the nutrients or contaminants that are present in this waste stream will concentrate in the solids, but will not be high in nitrogen. I am not able to speak to the ease or the plan for the solids management after we dewater it and make this cake, whether it's sent to a landfill, sold, land applied. But I just wanted to speak to the quality of those solids.
I would add the biggest reason is we no longer have water application. So you have to store the water in a lagoon for 4 months or whatever that timeline is. We can't store water with solids in a lagoon because the lagoon is going to be cleaned out every 3 years, which just doesn't work.
Is there a different system that would remove some of the solids that doesn't gas off nitrogen into the atmosphere?
I can let Consor add, we looked at several different options over time. I mean, the biggest removal solids, the clarifiers, right? The oxidation ditches are kind of separating solids, right? Clarifiers. Is there alternatives to clarifiers? It would be a cheaper alternative, Frederick?
Yeah, so not cheaper. So one of the initial value engineering concepts we had last summer was maybe we could change the secondary clarifiers. So secondary clarifiers could be replaced with a membrane, like a microfilter, which would take up a smaller footprint, but at a higher cost of the equipment. Secondary clarifiers are what I would call conventional technology. It's not cutting edge. It is large infrastructure, but you get a lot of bang for your buck, right? So with that large footprint, we have a large reduction in separation of liquids and solids. So we did evaluate other technology. Moving to a membrane type technology changes other aspects of the plant, adds different technology to be added, and the overall cost savings wasn't there for that. I did hear in there in the comment before about other options that wouldn't release nitrogen from the process, or nitrogen as gas. That actually is the most appropriate and environmentally stable aspect to do. The majority of our atmosphere is nitrogen. What we don't want to do is release a lot of nitrous oxide, which is partially processed ammonia to nitrogen to nitric oxide before nitrogen gas. So we do want to fully nitrify the process, which we are doing with this. Leaving it in the waste stream just increases that, would prevent our ability to meet the permit requirements. So we do want to fully nitrify and then partially denitrify our waste.
So it keeps referencing a permit requirement. Which permit requirement is that requires nitrogen to be removed via secondary treatment?
Austin, I believe it's the water pollution control permit, correct?
Yes.
Yeah, but like what specific? Because I mean, I read through that a time or two, and the only reason, and Justin, I mean, you're on, correct me if I'm wrong, or Smith, but the only thing that required secondary treatment to below 7 parts per million was if we were going to continue to winter apply. Did I misunderstand that?
No, Jake, this is Justin with DEQ. No, I can confirm that that is the winter limit that applies. And so my understanding from the port's permit mod number 4, we allowed more time for the secondary treatment redesign. There's an actual due date for September 1st, 2025 for a secondary treatment redesign report for DEQ. But my understanding in the direction the port was going to be looking at was looking at secondary treatment that would not necessarily reduce down to 7 milligrams per liter, but would stabilize the nitrogen in the effluent to a concentration that could be beneficially used strictly in the growing season for the farmers, but doesn't have to remove all that nitrogen down to the 7 milligram per liter, which is a disposal limit. So what we're looking at for the port to do is reduce nitrogen to a point and have a stable waste stream they provide out to the farmers in the growing season for a fertilizer input and a hydraulic input, but it doesn't necessarily have to meet 7 milligrams per liter in the growing season. And I understand your point, Jake. We don't want to have the effluent be taken down to a point necessarily where you lose the benefits of the nitrogen to be applied for the farmers, because all you're going to do on the other side is buy fertilizer and have fertilizer inputs that go into the process. But Frederick, you can probably speak more to the applicability of that to be able to sometimes get down to 7 if the port needs to get to that limit for winter application for any processes they propose, versus being able to dial back the treatment system, for instance, to get to, say, 30 milligrams per liter. It's all about the hydraulic and the nutrient budget that the port needs to move all that water from year-round application to just applying in the growing season.
But just if I hear that correctly, if the nutrient balance exists, the nutrient and the water balance exists, and we are not going to apply during the winter, then there's no requirement for secondary treatment.
There is a requirement in the permit for secondary treatment to be designed. It does not have to meet the 7 milligram per liter limit, Jake.
So would a clarifier to remove some of the VOD that would cause issues in the pond count? I guess, I mean, we need to define what secondary treatment is, right, from that standpoint, because
yeah,
the cost of
Well, I mean, I think it could be multiple approaches. It depends on what the port's engineers decide to propose, but it's about treatment technology that can provide a beneficial use. Part of the port's portfolio is growth, right? I mean, as in my understanding for the port is new campuses for data center development, new flows, increasing flows over time. When you take all that water and you move it just to the growing season and you no longer winter apply, you've got all that hydraulic to manage and you've got the nutrients to manage. And the port does not own all their acreage for the farms 1 through 6. They own some acreage now at this point, farm 1 and farm 6. But what you want to have is some redundancy and ability to be flexible for the port to have a balance that supports you guys for your growth for hydraulics and the nutrient budget for the farms that you have and the farms that you guys own and control the crops.
And Jake, if I could, just to clarify my statement about the target treatment goals, is our target of 10 to 7 milligrams per liter is our design and redesign has the ability to meet that when needed per permit and per time. The operator, Chad and team will have the ability to adjust this treatment process and that nitrification and denitrification process to be able to produce a higher concentration of nitrogen, but we need to, I care about every point in between, but we need to be able to manage the boundaries and provide the ability to meet the boundaries. So that lowest ability and that highest. So I apologize. I was only speaking about that lowest boundary, but that doesn't mean the plant doesn't have the flexibility to produce a higher concentration of nitrogen when managed that way.
My question, what would the role of this secondary treatment be during the growing season? Would it be mostly to remove solids or would it denitrify?
The biggest driver we've heard consistently from DEQ is having a consistent effluent. So that's their biggest concern is water being applied to fields that's doing this in nitrogen content and not knowing what's going on during the application process. So the only way to make that consistent is to remove X many milligrams per liter of nitrogen to make it consistent.
That's a concern for the farmers too, because there's a calculated number that we don't see in the field. It's hard to quantify that.
So long-term, dialing it back from 7 or 10 milligrams per liter is easy, and it definitely helps operational costs because all of a sudden we're not oxygenating as much, we're not adding as many chemicals. I mean, you can bypass part of the water to do blending, post-treatment. I mean, there's all kinds of things to do operationally to drive operational costs down. But to have the ability to move nitrogen in the water is the...
So right now, the nitrogen is calculated based on ppm sounds. Harsh. And it doesn't work very well. It's very hard to manage. And so is this going to be nitrogen as nitrate in the water?
Yeah, if with the existing secondary oxidation system or the proposed one, Frederick, most of this is going to be nitrate.
Correct.
The remaining effluent, yeah. Right now, you've got about 90 milligrams per liter total TKN. 80% of that is ammonium, and less than 1 milligram per liter is nitrate. After this treatment system, you're going to have 7 to 10 milligrams per liter of nitrate.
Well, that's not much use. I mean, if you talk about an agronomic input, that doesn't get you much.
It still doesn't work.
It's still not economic.
It doesn't work because you have agronomic rates to limit the amount that you can put on, and now you're buying it commercial instead of getting it through the most sustainable fertility source that we have. I mean,
and then one other point before we get too far away. Are these ponds gonna have an odor issue over the winter? With or without the secondary treatment?
Absolutely. So without secondary treatment, you're not removing the remaining 200 to 400 milligrams per liter of DOD, so you're going to have breakdown of organics. They have methane, H2S, the things that you smell.
Clarifier would remove that though, right?
take care.
You need air. It would remove part.
I said we can sell in the shallow of the pond and remove most of it.
I think that is a potential problem for anybody that lives east of the ponds. and occasionally on the other side.
Yeah. But is it going to be worse than what we have today? It's coming out of our digester. Is it gonna be as bad as it was before digesters 2-3 years ago when we used to have a lot of litter issues? Because it has been greatly improved.
That's a hard question to answer. I mean, we're just now getting digesters fully functional, you know, in recent history. It's still getting blended in waters that are in ponds that have been there. So I don't know how much you're gonna smell.
Can I maybe?
Definitely better, excuse me.
Well, I was just maybe, in Frederick, this will be for you, but just to preface, we'll chat about, we'll talk some about this if we get time for our short presentation at the end of it. When the whole group, I think when we talk about, we use treatment across the board, we use one term. And typically, we'll talk about this, the permit driver is nitrogen. That's the original intent of like the 7 milligram per liter. We talk about disposal during the non-growing season. So when we say treatment, I immediately think nitrogen, because that's the issue with the little bump. We've got nitrogen. But there's a bunch of secondary other reasons why we treat water, whether it's BOD, odor, H2S, all these things that even though they might not be an immediate permit compliance driver, they still need to be managed at the scale we talked about for everyone else. So I think, could you maybe elaborate on, let's say that we think we redefine treatment to say, we're targeting nitrogen, not to 7, but a higher limit that meets all the agronomic rate and nitrogen loading issues that DEQ is concerned about. So let's say that were to change. Would your approach on secondary treatment change if, for example, we had a target nitrogen of 30 milligrams per liter, and then BOD and others that were just as a management practice, not a hard effluent? You know, would that change the technology, as Jake's alluding to, would that change the approach?
Yeah, I could speak to that a little bit. I appreciate that question. So first, some of the other treatment benefits that come out of this process. When I think of secondary treatment, I'm thinking of reduction of biochemical oxygen demand, so that BOD demand and total suspended solids. So reducing that BOD, or that biochemical oxygen demand in the effluent that's being discharged, that actually will improve the quality of water that is used as it's applied or injected, specifically for crop growth as well, because your existing crops are not competing for the limited oxygen that's available in the water. So having higher BOD concentrations in that effluent has an inhibiting effect on the ability for crops, grass, turf, other things to grow because of that limitation of the oxygen. So that is more matching the natural aquatic condition in that habitat. Also, the reduction of TSS. Most of the pathogens, bacteria that are collected, about 40 to 60%, right? It depends, live in those solids. So by removing and reducing those solids, you're also reducing the potential and or the actual bacteria and pathogen loading of that effluent as well. So separating that liquid and solid stream provides you a higher quality effluent for that use. The ability, if you want to flex that nitrogen concentration, I don't think that would change my approach to this design, the existing oxidation ditches, and or the technology that's implemented. So if we want to not denitrify as much, we're actually going to have a little bit lower oxygen demand on the system. So we don't need as much air, therefore not as much energy into the system to drive this denitrification process. We're just going to be driving a nitrification process, which we still need air for, and we also need air for the reduction of the BOD as well. So it might not even, if we choose a different target or range of target of ideally where we want that nitrogen loading to be, I'm not even sure it would change the blower sizing to the approach. It would just change how many hours they're on during the day or how much oxygen is applied to the system. Because we still need oxygen to reduce the BOD. And ultimately, since we are going to separate liquids and solids, which does improve the quality and your ability to use that effluent of making that separation, the the process that's happening upstream is a digestion process. And so in an anaerobic digestion process, we're reducing volatile compounds. So the ability to treat that and separate those solids, we're really getting benefit for those upstream digesters by this dewatering system as well. You're inherently stockpiling solids in these digesters as well. This is giving you an avenue to bring those out as a liquid slurry or as that effluent and further separate those liquid and solids and manage those solids downstream. Austin, feel free to, or anyone else, feel free to add or differ.
This is Ian Taves from Lamb Weston. I just had a couple of comment and a question. I think one is that at the BOD levels that we're talking about here, I think I heard somebody say 200 to 400 milligrams per liter. I mean, that, you know, the impairment you see on crops is a significantly higher concentration of BOD than what we're talking about. So at least from our experience. And I guess the question I had is on TSS in the effluent of the digester, because that the solids keeps, you know, people, there's been a lot of comments on effluent solids from the digester. From a low rate anaerobic digester like the port has put in with 10+ day hydraulic retention time, you know, we typically see very few solids coming out of the effluent of a digester. So I'm curious what you guys are seeing there, what concentrations of solids that are coming out, because I think there's a lot of ways to manage those solids. If there are, you know, an anaerobic digester has very, very low, slow solids growth rate. So, you know, you could operate those often for 10+ years and not have to waste solids out of an anaerobic digester of those size. So get curious, you know, it seems like there's been a lot of discussion on the solids, but I'm curious how big of an issue that really is.
Yeah, I appreciate that question. Austin, I don't know if you could pull up or look at what our TSS concentration is that we're anticipating or know that's coming out of those digesters, or if Jake could speak to it. But if we're counting on 10 to 30 tons per day, potentially of solids coming out of the secondary process.
But those are solids being grown in the secondary process. You're growing bacteria to remove the additional nutrients, which is generating solids in the secondary treatment. It's not coming from your anaerobic digester.
Yeah, but that's not 10 to 30 pounds of microbiology, right? That is other solids in the system that are being separated. Austin, any idea what that number is that we know that's coming out of that?
Out of the digesters? I'm trying to find that now.
Ian, I appreciate your point, though. I don't have an answer for what how big of a problem or concern that is. I was just speaking to the benefit of the secondary process, how it's currently configured.
Yeah, and Frederick, maybe if I could follow up on that, the permit limit that's set, that's again for winter application is 20 milligrams per liter BOD, and I think 20 milligrams per liter TSS.
Mm-hmm.
Is that still the target?
Correct.
I think, I don't know, the farmers or maybe Lamb Weston or you better could say what the appropriate level for crops are, but I think part of my question when I was talking about nitrogen is also, if we look at if we're currently treating BOD and TSS to almost like an NPDES permit effluent limit, then that's looking at more, I think Justin, you could correct me here, but I think those 20 milligram per liter limits that are for the non-growing season in the winter, those are NPDES permit limits for like discharge, like for example, a river. And if we just need to treat to a limit that is appropriate for a land application to make sure we don't have a nuisance or a harmful condition or a nuisance to neighbors or it's beneficial for crops. I don't know where that number is, but I think Ian, maybe that's what you're getting at is what is the appropriate limit and have we over designed for a condition that doesn't exist? Right. Justin, I don't know if you can answer that.
Well, yeah. No, you're right, Joe. I mean, the permit was written to give flexibility to find that number for the design for the growing season appropriate for the crop. So, no, and you're correct. Those secondary treatment standards come from NPDES permits typically, but we treat those as disposal limits. And part of what the port is doing, though, is phasing out the winter irrigation program. So they don't have to treat down to the 20 milligram per liter of BOD and TSS limits in the permit for the crop growing seasons. We wrote that specifically for allowance for them to design a treatment system they could utilize within the growing season appropriate for the farmers in the land application program.
But would you have two standards then, one for growing season and then one for winter on fill? So you don't end up with an odor issue.
And Frederick, sorry, I'm trying to.
It's okay.
Ask you kind of question, but I think what I heard from you is that your technology wouldn't change, and Jacob and Chad chime in here too, but I think what I'm hearing is that your technology might not change, but how much air you feed to the system or how you operate the system, depending on whether you need it at 20 during the winter, or you can run it at 200 or 500 during the growing season. I think what you're saying is you can tune that.
That's correct.
Is
Yep.
that correct? And
Yep.
that would address your question.
That is absolutely correct. So I guess the cost.
OpEx goes down, but CapEx is the same.
Pretty much the storage is. All of that.
So how are we gonna manage that coming out on with two different levels? Cause I mean, one of Justin's things that he stated he was after was a more consistent, level of reuse, for us to be able to account for it. I think we could do that with a pretty simple study. But if we got two different kinds of water or two different levels of treated water, right? You've got the stuff during the summer that's the growing season water, we'll say, and then you've got the, winter water, that's designed for the deeper lagoons. I don't think there's farm or an infrastructure system here that is going to allow for the handling of either of those independently. Are they gonna, is the intent to blend those back into some other stuff and try to match flows somehow?
Jake, I think what would happen is all the treatment's gonna end up back in the 1.5 billion gallons of storage.
Sure.
And you should have that's gonna be mixing, you're gonna have that attenuation, so your influent nitrogen concentration, those ponds might go like this throughout the year, but the effluent's gonna be fairly steady because it's reaching equilibrium. I feel it's reaching equilibrium. So maybe that's something we could model. It's just a simple mass balance on, between November and February, you have lower concentration coming in. During the summer, you have a higher concentration. And then there's some average in the ponds because hopefully they're big enough where you don't see these big swings. So then that would still give you do you see what I'm saying?
I do, except for what I'm concerned about is matching up. So you're gonna have 1.5 billion gallons of treated water that we have to consume that doesn't hardly have any fertilizer in it.
Yep.
You're gonna have 350 million gallons roughly of a shallow pond that could be filled with water that had fertilizer in it. All the crop consumption of nutrients for yield is pretty much done by June.
Right.
And so from that standpoint, the lagoon water that's clean would be the last water, would have to be the last water to be used as far as trying to match up the timing of the more potent water, I don't want to say more potent, but stuff that's more useful.
I'm thinking,
Correct you, but the water should be treated the same all year round, technically, because we're not planning to applicate it during the winter.
right.
So why would we treat it at a higher standard if we're going to scale it?
I think actually you'd be treating in Frederick, this is what I think what I'm kind of getting at is. This would probably be described an operations plan, right? We need to figure out how much exactly you guys need when.
But I feel like that's an important conversation to have now.
Yeah.
We're trying to decide what's the appropriate route to go.
Because your guys' nitrogen consumption change, so you're gonna have your early spring, you're gonna have this peak, and then you don't need any for it, you just need hydraulics. And then you're gonna need maybe some later driven, right? And so we have to set that average effluent concentration in the water to meet these peaks, and so there's gonna be an offset, like you're gonna start treating the water 6 months in advance of when they need, you might change your operation.
So the way we manage that today is by growing different crops that need it at different times.
Right. So you're reactive to this rather than them being proactive to you guys, right?
Guess I answered that question. Why is it sounds to me like all of it's going to be applied in growing season,
Yes.
even the storage. So why is the storage being treated different? It's going to be applied in growing season.
I think it's the odor issue. Is it an odor issue?
To be a big store. Okay.
I get that part.
That's a good question.
But the nitrogen part coming out, you know, that part doesn't, that part doesn't make any sense to me, unless that's a step in the odor reduction process, but, you know,
So I don't even want to ask this question, because we've been working on this thing for like 2 years, but what happens when we get rid of denitrify? So basically the anox basins in secondary treatment, and you just went to a pure off ditch with the minimalization of the anox basins, right?
Yeah, so not having the anoxic zone in this system, and the anoxic zone is where we actually denitrify or have the ability to denitrify. So when we go to a true just oxidation system or an aerated system, we end up nitrifying and only nitrifying and doing the BOD reduction. So changing the process design to not have the anoxic zones, which is where the denitrification actually happens, that step back after the nitrification, wouldn't change the physical footprint of the infrastructure. It would just change the zone that we're not aerating, and therefore it might actually increase the capital cost because we would need more air to aerate that volume that we're not currently counting on being anoxic. So just off the cuff from the hip, I don't think it would change the footprint of the infrastructure and could increase the capital cost for more air to the system, and it would remove your ability to denitrify if needed at any point.
And Frederick, wouldn't then all the nitrogen be in the nitrate form, but not reduced? So we basically turn all that, let's say 80% ammonia, convert over to nitrate, but then we wouldn't reduce total nitrate.
That's correct. There is some natural denitrification that occurs. So again, not that some of that there's a simultaneous nitrification, denitrification that could occur. And as it's discharged, right, and blended as it touches other water, the nitrogen compound is going to want to stabilize as nitrate, not as nitrite or, back to any other form. So that is correct.
Is it possible to, I mean, to your point, if you just are oxidizing, aerating to reduce BOD, now granted in the 90-foot deep pond, that's not possible, but I mean, you can aerate with surface aerators, or if it's too deep, you can do, aeration at the bottom of the pond to aerate to reduce BOD and manage odor. To your point, it wouldn't denitrify in that system, but it would manage odor. And if we've got the nutrient balance that would allow for, the concentrations, that would be expected without the denitrification, you could essentially just do your secondary treatment in the lagoon, in the lagoons and not have to have the additional system.
It's possible. It's really just a question of energy, right? The amount of energy it takes to get the air in to mix that process. And in that big of a lagoon, you really just lack control. So, just things that run through my mind is you might need to segregate sections of that existing lagoon to try and, recreate a system that you can control. So it's the mechanical style, hardened system gives you a process that you can move flow through quickly in a controlled environment. In the lagoon, you're not really in control. So the ability to maintain and the confidence to meet that compliance on the other end, just that risk goes up.
Right. But $178 million or whatever it is after value engineering, that's a big price to pay for some of those, niceties.
Yeah, absolutely. I'm not denying that. I also don't know what the cost would be to add that and make that work to that lagoon either. So.
I have a rough idea on operating cost. Annual one.
The question was, what is the annual operating cost?
Yeah.
Austin, do you recall that off your head? I do not recall that. I know we've penciled something out.
No, I do not. And we haven't taken a look after value engineering.
So we ran this analysis. I sent console request just a couple of weeks ago to update based on the value engineering. We took it on ourselves and went through an estimate with the value engineering of what's proposed here, and including current digester costs as one system. At startup, we're about 3.4 million annually.
And operating stuff.
Yeah.
And that'll go up or down or stay.
So, the biggest contributing factor is the amount of water you're treating, that is energy and chem costs. Labor stays pretty constant. So at full capacity, of running the systems to capacity, it ranges up to $4.6 million per year. But at startup, at current flows, we're about 3.4 million.
Not including the biosolids program.
That's,
Not including biosolids program.
I didn't include solids handling.
Which will be roughly another $1.5 million to land to collect the solid. That way.
And it would be ballpark $50 a ton.
And great, there's not a permit on it, but explain to me how.
I would say the same thing, Craig. How is there not? Because dirt coming out of the plant that I assume they've got to have a permit for to put somewhere. I don't know exactly, but
Yeah,
my question would be, how come it's not?
1% dry matter versus 17% dry matter, what magically changes to make it sustainable?
It's an agricultural exemption, right? That's right. Yeah, there's just an agricultural exemption on. Agricultural
It's
costs.
already being applied there. And it's
already being applied.
Yeah, I'm not, yeah, that's, I fully, yes. Yeah, if you're asking why it is, it's just law.
And if you get over the hurdle of the group think that we need to put on less fertility because our current ag systems are polluting, which is factually incorrect. But if you get over that hurdle, and so let's say we want to put 300 pounds on, we only want to put 100 pounds on, okay, fine. Explain to me the difference on whether that 100 pounds comes from synthetic or manufactured fertilizer or Port of Morrow fertilizer. What's the difference? And why do we need to treat it? Why do we need to spend $5 million a year in OpEx? Why do we need to spend $5 and 1,000 on the discharge? I mean, I'm not challenging the concept. If you have to be able to appreciate the irony of what was said about you spend $200 million to remove it out of the system, turn it into a 17% solid product, go land apply it somewhere else, and it magically is okay now. I mean, there's an inconsistency there that costs a lot of money.
Also, the other cycle is the nitrogen cycle. You're pumping the nitrogen out into the air, and then you're using natural gas to take it out of the air and put it into a fertilizer you can put on the ground. Yeah, you've added a step in the middle that didn't make any difference.
Yeah, hey, we do have for ours, we have a little figure on that to maybe kind of highlight that, but just to expand on Vic's point, part of what we wanted to talk about at the end here is exactly what you say, Craig, what's the difference? But then at the end of the day, it doesn't really matter what happens upstream, whether it's commercial fertilizer or reuse water, because there is a cap on how much these farmers can put on their field. It doesn't matter where that comes from, it's just simply a cap dependent on the crop and everything else. And so you can spend $1 billion taking it down to 0 reuse water nitrogen, but to grow alfalfa, you want maybe corn, there's a certain amount that you have to apply. And so if it's just not the reuse water, it will come from fertilizer. And for anyone who's concerned about groundwater, that cap didn't change. Just because you spent $1 billion on the treatment system, the cap is still there. So that same amount of nitrogen is going to be applied, and people are still going to be disagreeing on whether that nitrogen comes to the groundwater or not. So until that conversation about the nitrogen has to apply at the field level and what the economic rate should be, and then if there's a method to measure its potential impact to groundwater or not, it doesn't really matter what happens upstream.
Exactly.
If we can't agree on what happens at the ground surface.
And by no means, to be crystal clear, by no means are we being cavalier about the Lukewarm issues. And by no means are we saying that we don't need to get nitrogen out of the water. And by no means are we saying that we disagree with the trend analysis in some areas. We're not saying any of that, but you are throwing the baby out with the bathwater by spending 200 million bucks on doing some of this stuff. They're two separate issues.
The real key is that we'll be able to manage the hydraulics better, but not without the winter run. And so whatever we do, we have to be able to manage the water in the pond over there without creating another problem.
Yes.
But doing away with the winter run lets you manage the hydraulic situation, which is gonna lower the potential groundwater issues.
That's, yeah, thank you, because I'd like to adjust what I said, you're 100% right. It might help manage, I think what I'm trying to get at is if the thought is that by treating the water all the way down to even zero, we think that we would then be able to measure all of a sudden the groundwater is clean. We can't answer that question until how much is applied is answered, or like what the appropriate is applied. So yes, it will create more operational flexibility, it will do all these positive benefits. I'm not saying we shouldn't do it. It's simply 5 years from now, after let's say the treatment system's in, and 20 years from now, is there a method for us to look back and say, look, we did this right at this point, and now we see an improvement? And what I'm worried about is that no, the framework isn't there for us to assess whether this was, if we got the bang for our buck. By looking, and we were able to say groundwater has improved based on this. And Justin, I would just say, if you have thoughts or disagree on where we're at with how the monitoring would translate into that, like feel free to correct me there. But just from what I've seen so far, I'm not sure we have the tools in our tool belt right now to say we spent $150 million and 5 years from now we saw this measurable improvement in groundwater quality. Because there's all these, like I said, there's all these other issues that we were going to talk about that we haven't resolved yet. So.
Well, and Joe, I mean, we do have the monitoring well network for the facility, but we've talked about additional tools that the port or others could implement, like measuring nitrate below the root zone, for instance, or lysimeters or some other testing. The port is under a remedial investigation feasibility study. That's because of impacts to groundwater from operations. I think overall, there's a lot of good steps in the right direction. Winter phase out is a big component of that. Hopefully we see really good results from the down gradient wells at the port's land application areas with the cessation of winter irrigation. We saw that with the city of Boardman. If anybody wants to see the city of Boardman's results from their reduction in winter application and cropping practices, they saw nitrate go from 40 milligrams per liter down gradient of their site to below 10 in a couple years. A really good improvement. I mean, we're certainly hoping we see that type of improvement with the port, with the changes and reduction in winter effluent. But getting reduction in nitrogen will help again with the balance for nitrate and nitrogen going forward for the cropping practices, and provide that ability for the port to have flexibility. Say if there's a land application partner that wants to remove themselves from the program or drop out of the program because, as I said, the port doesn't own all their acreage, that puts the port in a real bind with nitrogen budget if someone does remove themselves from the program, or if we see issues with groundwater contamination down gradient of the port sites that continue, say at Farm 1, Farm 3, or Farm 2, and we have to make reductions in things like agronomic rates. I know there's a lot of discussion on those at this point, and we're being flexible with some of the application procedures for agronomic rates, but not removing nitrogen and not having a good nitrogen budget for the port with the growth opportunities that are seen and projected from the port puts you more at liability of not having a good nitrogen balance going forward and potential groundwater pollution concerns. I don't think any of us in 5 years want to be sitting back here saying things got worse or things didn't improve with the amount of capital being expended at this point. But Joe, I mean, we've got groundwater well networks at the sites, which is what I was getting at. That are the tools that we utilize to assess effectiveness of the land application program. They're one tool. They certainly don't monitor everywhere, and I think we can get a little bit better about that. But the hope is we see improved groundwater trends downgrading of the port site specifically, not the entire Lub Guama, because that's not the port's footprint, but the port site specifically after these measures that are being taken through the permit process.
Yeah, no, thanks. I think that's a good point, Justin. Part of what I'm getting at, and this is what I was gonna kind of flesh out a little bit more, is like, for example, like so I understand we've got upgrading well on like a port a port farm and then a downgrade well, we can look at that. And certainly you can try to look at that relative to background, but in a lot of cases, you know, I should preface, I'm not a hydrogeologist, so, you know, I leave that to the other hydrogeologist team, but from what I've looked at, in some cases, we've got water coming onto the port's property upgraded that's 30 to 50 milligrams per liter, right? So it's 3 to 5 times above the drinking water, and it's not the port, it's coming onto the port's property, so the port hasn't had any impact on that. And my concern is that if let's say this gets back to the economic rate, why I was talking about why it matters, what happens at the point of actual land application is a change in an agronomic rate of 10 to 30 pounds could be, I mean, you guys correct me, it could be the difference of whether you guys think it's viable to stay in the program. But when you've got a background concentration of 30 to 50 coming out of the port, DEQ's ability to say, I've changed the agronomic rate by 10 or 30 pounds, that has a huge impact on their viability of the program. The sensitive, this isn't about like whether this is a good idea or bad idea, it's more about sensitivity of scientific data. Do we have the sensitivity in our program to measure that change in the economic rate and see if with a background of 30 or 50 milligrams per liter, we actually improve groundwater quality? And again, I'm not a hydrogeologist, but from the data I looked at, it's like, it might be 5 years before that change actually would show up in the data. And the ability for us to even look at that well data and say, look, we made that management decision that cost millions of dollars in the change in my farming practice. And here's the benefit. And Justin, this isn't like saying anything about whether we're using the wrong, it's more just the margins that we're operating at to keep things going in the program. Do we have the scientific tools available to actually say, yes, this management decision resulted in this benefit in protection of groundwater? And that's where the margins are so tight with some of these that I'm not sure we do. So anyway, that was the origin of my question.
Yeah, good point, Joe. I mean, I think we're trying to work at some of those things through the pilot studies. I know we just got a pilot study report back, and I think that's where we're trying to answer some of those questions too. And we're certainly happy to keep working forward with the Port, Lamb Weston, and others on those types of pilot studies that do get at some of those gaps in the data, for the cropping questions at least.
Yeah, and that's actually one of the response to my own question is one of my responses. So yeah, great.
So is there any more questions for Consor? I want to give Madison time, so we're not running short on what they have.
I was just going to be quick today.
Okay, well.
And
Parametrics got a small one too.
there you go.
Add,
So I got one question on the cost of this, and so hypothetical, right? I mean, this is something that I think we would need to discuss as a region. We pull the trigger on this, and it's incredibly expensive. The O&M cost is expensive, and it does everything that everybody thinks it will. If the cost of this puts the cost of doing business in Oregon too high, and industry relocates, or no more new industry comes here, the port will still have debt service on this and on everything else. The farm, I mean, the farm they can sell, right? From that standpoint, that's not a stranded asset if they needed to. This would be a stranded asset. Who pays for this if no more industry comes or if industry leaves?
Hopefully we have permits, hopefully we have contracts in place that cover the duration of our funding.
No.
Farmers,
No.
businesses.
Nobody's gonna sign a contract today. Nobody has any idea what these numbers are. You just got through this big presentation. You have a limited window on knowing what the operation cost of this system are. Nobody is gonna sign a contract not knowing what these expenses are gonna be long term. That's just business 101.
A contract for farming partners, you mean?
No, to take the water.
To take the water.
To do business in the port.
To discharge water. You have long-term farming agreements.
Yeah.
And And to say that your whole system is at risk because what if one of the application farms goes away? Then what are you gonna do? You're gonna go buy 50,000 acres of dry land to apply the solids on, or are you just gonna haul the solids all to the landfill? They don't magically go away with this treatment, they just change form, that's the whole point. And instead of putting it on irrigated ground where we're monitoring soil moisture and everything on a daily basis, you're gonna take it out to a dryland area. You know, and apply it that grows a marginal crop every other year.
So you're saying that the water itself has no value?
I didn't say that at all.
Well, then why wouldn't we be able to sell the water once it's treated? I mean, everybody's looking for new water rights and
That's not-
water for farms.
That's not the point.
It would still be under a DEQ permit.
Of course it would, but you're still selling.
Nobody's gonna pay for that.
Why? Why, Jake? Is that, you're saying the water doesn't have any value? You're just saying that the nitrogen has the value,
No.
but why doesn't the water have the same value?
The permit takes it away. The water itself, yes. there's
You're saying that the cost to monitor or comply with the permit regulations outdo what the value of the water?
Yeah, absolutely. That's exactly what I'm saying.
What's your?
Are we paying those or is the farmers paying those?
Saying what?
For the permits, all of the monitoring, IRZs, monitoring wells to them?
Can I?
I'm asking is the
So
port
Kelly,
does.
kind of what I was getting at. Even if the port treated the water down to 0 milligrams per liter, so there's no nitrate, it would still be classified as
Yes.
recycled water that has to be permitted through DEQ.
Okay.
And as soon as someone takes one single drop of that water, all the agronomic rate limits and how you can farm kick in. So the farmers who are part of the program are treated very differently than someone outside the program. who
I
has no-
understand all that.
So when they say the value change, if you can have all this water, but if you can't grow a crop at a certain market value and you're dictated how you have to farm to be overly protective or protective groundwater, then it's completely different. It's not a business model. It's more of a.
It's a liability.
It's a liability.
I get
So
that.
I think that's what they're trying to get at. It's just like the water is valuable, but it's only valuable for its end use. And if your end use is building Lamborghinis, that has a different value than if your end use is, filling up your home swimming pool, right? And so they're two different, maybe that's not a great analogy, but the point is just like, they're very different. They're very different, end uses, and so it's only as valuable as what you can use it for. Under a regular WPCF permit, you are put in a certain box.
So there's a cost to disposal, and I understand that. But there's still a benefit to the water, to the clean water. And I think that you could find growers in lots of areas that are looking for extra water rights.
Tell you what, you find some growers that wanna sign up to farm under these permits,
You have that.
you can have it back.
We're gonna quantify that for you, and that has to click with the commission. Because these are real numbers, and this is a real expense, and it's a broken system right now.
Yeah.
And we're not arguing over whether or not we need to clean up the groundwater. There's no question that people need clean drinking water and we need to clean the groundwater. And we've proven that we can do that. But what you're doing right now with the agronomic rates and with the Port of Morrow permit is adding cost to the system with no benefit to what you're trying to deliver.
That's because it's the cost of doing business, correct?
No, it's
It's gonna
not.
be the cost of not having any.
It's not the cost of doing business.
Then it has to be,
Contracts with our industry. We don't have contracts with them.
It seems that our regulatory agencies, though, our process doesn't include the option of removing secondary water treatment plant, correct? Would need to be modified to do that, or am I mistaken?
you're correct.
I would think only for winter application.
No,
I thought it was just, we had to design.
It doesn't say you have to spend 135 million, that's for damn sure.
Justin just told us that.
Yeah, and Justin, I think the permit is written where you have to have, right now it says you need to have secondary treatment. But I think what you said at the beginning is, the reason for that was, it was under a certain set of conditions before, that was set in there some time ago, but I think correct me if I'm wrong, but what DEQ needs to see is, what is the board's plan for, protection of groundwater? And that means meeting the agronomic nutrient loading, the water, the whole thing. And how the port meets those requirements under law is up to the port. Up to now, the path has been a secondary treatment system with a defined set of technologies, but if the port were to come to DEQ and say, we think if we have this amount of nitrogen, BOD and TSS, and we have this many acres and, you know, this average concentration, we can show that we have capacity to protect groundwater while operating under beneficial use, right? Like, in other words, is DEQ being prescriptive that this is the technology we need for the secondary treatment, or is it saying, find a way to be in compliance and then show us that? I mean, it would require a permit mod if we change course, right? But I get, do you see what I'm saying? Like, there's what's in the permit now versus the intent that you described in the beginning.
Yeah, I understand the question. I appreciate that. I'll provide a brief comment here, and I don't know if Justin or someone else wants to weigh in. I do not believe that DEQ is being prescriptive about the technology, but this technology is in response to the water pollution control permit, which dictates or is directing for the secondary treatment level of quality and the interest or guidance for the consistency in that effluent coming out. And the decision on this technology in its current configuration and this plan is in response to the regulatory permit requirement, not in response to a overall holistic approach to management of groundwater quality and or effluent and solids management, nutrient management in the area.
It's a great point, and don't get me wrong, if you had a comprehensive plan that said this water was $6 a thousand to discharge, awesome, great. Why wouldn't we want to put secondary treatment in? But in the absence of truly understanding what the optic says, and whether that's palatable to the industry, and whether it's truly sustainable from a carbon footprint perspective, in the absence of having all of those elements, it's an incomplete business plan. You have to have those, elements, and we hope that we're proven. It would be awesome. It would be awesome for us to have a consistent water that when we turn the switch on, we knew we got 20 pounds of nitrogen. It would be great. But it has to fit into the system of economically viable, and it has to make sense from a carbon footprint perspective. And if Boardman changed their cropping patterns on some upgradient field of a well, and dropped their nitrogen by 75% in 2 years, then we will look into that with everything that we've got. But if that is the basis for which this whole thing is being dictated, I think we need to do some more homework on whether or not that's possible. Because when you're 80 feet from groundwater, it seems difficult to prove the science out on how it changes in 2 years.
What is the consistency of water that comes to you now with nitrogen? Is it?
Well, that's a hard question to answer because they measure TKM. And so then when you do the math, there's 20 or 25 pounds of nitrogen per acre inch. That's the calculated number. But if you go out and you apply it, you go out to a soil test, it's very hard to find that. And it depends on the weather and it depends on lots of stuff. And that's part of our dilemma.
It is, and I think that was one of the things we touched on last week, right, or 2 weeks ago, was we need to spend some time and effort working with parametrics and with DEQ on fully understanding the fate of the water we're getting, right, and the nitrogen that's in that water. From that standpoint, how much of it's volatilizing, how much of it's readily available, how much of it takes time and heat to slowly become available. And I think that's a really important next step before we get too carried away on making drastic wholesale changes. Because I mean, I can tell you based on and the yields that we're getting and the stuff, the way we're trying to consume as many gallons as we can and make up as much of the nitrogen loading for the crops as we can with the reused water, and then seeing the yields we're getting, it's not what they say it is. And so from that standpoint, I think there's some pretty significant efforts that need to be made in truly understanding the fate of what's happening with what's in the water now. And I think part of it too is we need to have a secondary lab review it. We've used that lab a little bit and see a lot of kind of weird things from it. So, anyway.
Like I said, the discussion wouldn't be happening if this 160 million or 130 to 160 million dollars fed into a system where you could show that the cost of the industry was shoot even $8. You know, but it's an unknown, and the initial analysis, I think that Jacob and his team, you know, have ran is that you got the potential, because in main part of the agronomic rate issue, you got the potential to shoot up to 10 to 15 bucks. And then you're gonna have what's happened exactly at the Port of Pasco right now. They put in this, what was gonna be a state-of-the-art leading edge system, their costs are up 6x. And there are, in process right now, people are discussing relocating facilities.
I mean, what is the rates after we have a schedule in place for increasing 15% per year, generally speaking, for refuse, water, fees? What is any guess on the rate that would be at the end of that time?
Originally, it was 84, but it's probably 10 bucks.
Say that a little louder, Jason.
Originally, it was 84, but it would probably be closer to $10
At the end of.
by
of the
2031.
increases.
No, 2031, it was 8 something.
Because he is correct, the operational cost estimates are substantially higher than what we anticipated at the start of this process.
I'd like to hear from industry. We have industry in the meeting today. I'd like to hear their comments having to do with affordability, and if they would be so kind to say that. They may not want to, but if they don't, that's fine. I'd like to hear from them, though, please.
Is anybody want to speak up for that?
Well, I can say I've had some conversations with some the industries recently, and they are extremely concerned on operational costs. How much are they going to be able to sustain and be able to keep the doors open, depending on the cost?
Yeah, so Ian was there, but just dropped off.
Yeah, I'm here. One thing I can say is that, you know, from a corporate level, I get to see what we pay municipalities for wastewater treatment from site to site, and the projections that we've gotten so far, which is pretty rough, I think, and not modeled out all the way, would put the Port of Morrow at the absolute highest by a factor of 3 or 4 over what some of our normal facilities are. So it's a significant cost.
Thank you.
Yeah, I don't believe that was, didn't you send us out the comparables? The spreadsheet, I think I have that.
The comparables are not necessarily by Western location.
No, okay, that's fair.
Food processing, but not necessarily by Western. And freshwater is a fairly easy number to come up with. Discharge is not.
There was
several of the entity issues, a lot of factors that are individual to the waste streams to determine their rates. I will tell you though, the data center discharge rates, we are less than a quarter of the average rate that, not that that's been gallons or much money for us, but data center discharge rates in the area are substantially higher than we charge.
And how many, and to Ian's point, how many years was Boardman the lowest of Lamb Westons?
There again, it depends on what information you're getting.
Yeah.
But we were certainly led to believe that we were the lowest for a very long time.
For a very long time, yeah.
I think Kelly from like Weston.
Oh,
Sorry.
Too many Kellys.
So Kelly, Matt Weston.
Yeah, what was the question?
Oh, I thought you had something to say. You had unmuted earlier when Joe asked it, or John, somebody asked you. Industry had something.
Yeah, I just wanted to hear industry's input on the worry or not that they might have with the added cost. The rate increases that are already in place might be able to be modified if we didn't incur the debt that we're projecting out there.
Yeah, I think Ian did a good job touching base on the cost, right? We fully support the process, right, of being good environmental stewards, right, long-term sustainability. Just with my limited knowledge on this process, right, I think that there are other things we need to do more due diligence on to fully vet out and understand. For example, what is the benefit of getting everything cleaned out of the water so that farmers now have to pay for third-party artificial nitrogen, and what is the impact that that's going to be hauling that in, right? Lot of tangibles there, a lot of costs. What is our long-term strategy vision for our environment and economy here, right? And so I think we just have to do a little bit more legwork, seek to understand everything. A lot of questions it feels like we still need to answer, but specifically to costs, I did some rough math, and it would be about a 242% increase to my costs in the next 5 years. And that is the lower end of everything I'm learning. So it could go up.
My audio coming through okay now?
Yeah, go ahead, Brian.
Yeah, and I'll just add to that too. I think the concern comes from, we really haven't seen good cost projections yet from the port. We put together our own cost projections of what we thought this would be. I think Madison has done that as well. And so the reality of it is, I don't know we have much to go on in the way of understanding what those true projections are from the port at this point. That's been a big concern, trying to understand that. I think if you look at what was shared, freshwater goes up at the same rate as wastewater goes up. And I don't know, that gives a lot of confidence to understand why freshwater is not changing. And so those that don't use the wastewater treatment as much have the same cost increases. So helping understand what the details are, I guess, as far as what these cost increases, the basis behind those are from the port itself, will help to give us some level of confidence of all these capital costs plus the operational costs, where we're actually going to land.
Okay, one quick thing before we get to parametrics, on John's question, just for clarification of what is required by DEQ of us today. The secondary treatment is not required of us today.
It's in our compliance plan today.
So that's in our mutual agreement obligation.
But it doesn't define what secondary treatment is.
It doesn't.
Justin.
It's in the compliance schedule of the permit. Lisa, is where that resides. It's not part of the MAO specifically, but if you look in Schedule C of the permit, that's where the schedule for secondary treatment design and deliverables are included. And that includes a nitrogen hydraulic budget estimate that has to be provided. But again, we gave the port more time through the modification number 4 of September 2025 to provide a proposal to DEQ. And part of the discussion, as was referenced by Consor, was adjustments to the secondary treatment infrastructure that don't have to get down to that level of nitrogen treatment, but provide a consistent effluent stream that would address odors in the ponds and also address nitrogen budgets for the land application partners. So that schedule is in the permit. But it does not prescribe a technology. I know that question was asked earlier. There is not a prescriptive technology requirement for the secondary treatment system. So, oxidation ditches is not required by the permit. We can't tell the port to put in a certain treatment technology. We leave that to the port and their consultants.
it seems like time is of the essence here a little bit. How do we get these answers in the time that we have? Whether it's whatever it is we've talked about in the last 2 weeks, economic rates hopefully increasing, or consistency of the water coming out. How do we make a decision away from possible consistent tap that I can have confidence in, and I can go to the citizens of Oregon and tell them, guess what it's gonna smell like now? Because we didn't do that. Tell me how I address that. Tell me how this process changes from secondary treatment to a system that benefits more people and everybody in the chain, actually. Port, reduce operating expenses for clients here with reduced costs in the long run, farmers with nitrogen that they don't have to go out and buy. Tell me where does that land? Where do we hit that spot?
I couldn't ask them, but that's the question.
Okay, we don't have a lot of time, right? So how do we get the answers?
If I could,
No matter what you do, you're not gonna have secondary treatment in the pond this winter.
Okay.
Now, if you start building today, it won't be done.
That's a good point.
So you're gonna get through one season and see what happens.
You don't have to have them 90 feet deep though.
if I
redesign it now, then.
Well, I mean, yeah, at this point, that's another trend cost, right?
And if we went and bought Farm 6, we wouldn't even be having a discussion of no secondary. It wouldn't be a discussion. And one other benefit, well, because we have clean water, we didn't have enough acres to spread the loading out. Now we do. We have the acres to spread the loading out at about 30% extra acres. Currently, right, I think is where we're at. Good economic assumption. Yeah.
Yes.
One thing that does work though, if we do secondary treatment, we can get rid of most of all of our water on farm side.
Say that again.
Mark, did you hear Kelly ask?
I ask you to repeat that.
If we do secondary treatment, we can get rid of most of our water on farm 6, if not, it's ridiculous. With farm 5, then we have at least.
And Mark, if I could, I had just one comment to the point of the question from the board, right? We understand and we heard cost certainty. In fact, that was the purpose and really the primary point of this this value engineering effort, was to help determine cost certainty so that the port could understand both the capital cost and we could refine that operational cost, so that could be about included with other evaluations and be used for decision making. So where we're at with this effort, we have very defined quantities and process and systems. We're going to have the ability to get very current and accurate capital cost with negotiating with the current apparent low bidder, and we'll be able to use the current redesign effort to help the port on the projection of that long-term operating budget of what it will take to operate that, so that can be better considered and understood. I understand the paramount of cost certainty in these things, and part of this effort was to refine and get to those numbers so that there's less ambiguity or less unknowns in that cost. And that's part of what we're working on, but that only defines the cost of the secondary treatment as part of the solution, not the other alternatives.
You have to look at the numbers. I mean, if you put secondary treatment in and you put all your water on farm 6 and you still have the agronomic rates, then you're gonna grow 5,500 acres of alfalfa that you're losing $300 an acre on, and you're gonna add $5 million of OpEx, and you're gonna add $200 million of CapEx on a farm that already set a market high in price.
And the pipelines through there aren't big enough to drain the ponds and take your flow.
And that may be the best option, but you have to look at the numbers.
We just indemnified all of our farms, removed the port's protection as a public entity. I have issues with that in some respects. So I'm gonna listen to all arguments, and I'd like to see the numbers, honestly. So I didn't understand your comment though, Jake, what was yours?
The pipelines on farm six, they're 16-inch laterals that go out to the farm, the whole black water. They're not big enough to move all the water in here. So, I mean, there'd be some additional infrastructure costs on that, it's not super simple, but.
Okay. Well, so for this, the factor of time here, if Parametrics has information they want to, yeah, that's it.
Yeah, I mean, whatever, if you guys want me to go next, we talked about the economics a lot already, and that's kind of what I was gonna. So I have a couple slides, we were gonna go a little deeper, you guys had questions about farm budgets and what goes into them, we're gonna talk about that. We're gonna talk about comparing reuse yields and numbers to to commercial farms. I think that those spreadsheets, you guys can see them, it's much simpler, it's not as much detail, but you can see the net effect. And then I threw the model in if you guys want to look at it, but I mean, you have the land base under contract now to accomplish everything you need and have some very significant growth. Then we apply the fit for purpose concept that we talked about last time of matching the crop rotation for the purpose of consuming, water and nutrients. So from that standpoint, and again, we want clean groundwater also. We want the region to succeed, we want the state to succeed. So I'm not offended by any of these conversations that we're having today about secondary treatment, about that. I just want to make sure that we're having really good conversations about it and understand everything that we're doing. If you guys want to hear from Parametrics, that's fine. If you want to hear from me, it doesn't matter.
Yes, Lisa.
Does anyone want a 5-minute break?
That's a good. Let's take a 5-minute break. Is that fair?
Region, this is. It's gotta be. It's that. What's that? Yeah.
Okay, so we're back from our break here. Parametrics is gonna do a presentation and then we'll run into Madison Ranch's presentation. We're all good, Brandy, on recording?
Yes.
Okay.
That's fine.
Sorry, you get ready to go.
Okay. Sounds good. All right. And you'll share it there.
He's got it.
Oh.
We're ready.
Okay. All right, well, I'm Joe Mitchell from Parametrics. I'm here with my colleague, Lauren Greasy. The purpose of my presentation today is, I'm not coming with a distinct set of solutions or anything. It's mostly in our role as helping the port with the OM&N plan and basically coordinating all the different parties on compliance with their WPCF permit. What I wanted to do is basically take some of what Consort presented today, the solution, some of the concerns like the farmers have brought up, and then Justin trying to think like how you might approach environmental protection and come up with a set of more questions and unresolved things that we see as no matter what decisions made on secondary treatment, we see these as still being hurdles or challenges that need to be resolved so that we can have some certainty on what permit compliance and then ultimately groundwater protection looks like long term. So and Consort, some of what I'm going to share you kind of already heard what I was asking some of the questions on the targets and everything. So none of what I'm saying here is meant to be critical of anyone's approach, whether Consort or Justin. I'm going to have stuff on how I perceive DEP approaching things. This is meant hopefully to generate some discussion and questions so we can clarify. And then ultimately, Parametrics, a lot of times we're helping work on a strategy that checks everyone's boxes, all the interested stakeholders. So that's hopefully what we're trying to get out today. And as always, feel free to stop me and ask questions or open a discussion if needed. So topics will be just the original purpose and goal of secondary treatment in terms of the WPCF permit. looking at shifting the nitrogen source from reuse water to commercial fertilizer, which we've already talked about a little bit. Energy considerations of secondary treatment, and then other program barriers that we think, like I mentioned, are going to be an issue no matter what secondary treatment solution is chosen. Okay, so the original purpose of secondary treatment, this is from the permit fact sheet from a few modifications ago. It's very small. I'm going to read a couple portions just for everyone. We've discussed this a little bit already, but the first portion, it says treated effluent must meet specific wastewater effluent limits during the non-growing season, while additional storage is built according to the permit compliance schedule. The permittee must use the treatment system in the growing season to ensure permit compliance. Then the second part, the total nitrogen limit is set at 7 milligrams per liter as a protective measure to be below the drinking water MCL, and at 10 milligrams per liter, and at the 70% MCL that declares a groundwater management area, and are to be met for winter irrigation activities classified as disposal once the treatment system is built. Okay, so again, the original intent of this was disposal during the non-growing season, needing to hit 7 milligrams per liter, which is below the 10 milligrams per liter drinking water standard, and also to be in compliance during the growing season. The permit doesn't say that you need to hit this amount, doesn't say you need to hit this certain threshold, it says just for compliance during the growing season. Right, so that'll come up here in a little bit. The other piece of this, down below, we mentioned this, Frederick and your team, this is why I was asking about this, so total nitrogen in the A1 table is the 7 milligrams per liter. This is what.
The TV, it absorbs it, the TV.
Oh, okay, cool. All right, and then TSS at 20 and DOD at 20, and Justin, thanks for confirming those are NPDS permit limits, so that's why I say maybe there's some. I want to make sure that Frederick, your guys' team and the holistic approach to land application nutrient balances, considering where those could be. The last part here, beginning November 1st, 2026, all wastewater in non-growing season from February through February is to be stored in lined lagoons and not land applied except as approved by DEQ for beneficial use using treated wastewater that meets the table 1 limits. Examples are beneficial uses include field preparation, limited dust control, crop uptake, and shoulder limits. So there's some beneficial use there as well. So now obviously we've got 1.5 billion gallons worth of storage funds coming online this year. The permit was modified, recognizing that since those are coming in now and we will be able to store during the winter, secondary treatment can have a longer time frame to get installed because we're already storing in winter. We don't need to dispose during the non-growing season. However, the question is, and I think what I'm trying to bring up is, and for my hopefully not too pressing questions to the council team is, when we got that extension, did we come back and revisit these numbers to say, is this, Jake, I think you said, is it fit for purpose? Is this meeting what now the intent is, which is compliance during the season, which is more referring to how much nitrogen is being applied, and is that amount protecting the groundwater?
Use this one.
But also don't smack me with it. So that's the, I think that's the key takeaway for that piece of it. So the next part of this is what I want to highlight. We're talking about groundwater protection and the purpose of treatment. So right now with the current secondary treatment system, I want to highlight where water reuse, what water benefit water reuse is provided. So in 2023, we have to compile all the data that gets submitted to the state. So we went back and we looked at in 2023, how much of the nitrogen that was land applied in the port system was reuse water nitrogen versus commercial fertilizer. And the chart over to the right shows in the kind of light green, the big piece of the pie, 1.5 million pounds of nitrogen that was used by the farms came from reuse nitrogen. The next largest was about 144,000 pounds of nitrogen came from irrigation water, meaning fresh water that just has nitrate in it. And only 78,000 pounds came from commercial fertilizer. Now, this is based on, back in 2023, I think we were using the 70% TPN rule. I'll get into that later. We don't need to jump on that too much right at this point. But the key here is that if we take that current level from about 90 milligrams per liter of total nitrogen down to 7, and concert notwithstanding what we just talked about earlier about maybe a different level. That shift from 1.5 million pounds per year is going to shift over to commercial fertilizer. Because it doesn't really matter, the farmers still have to grow a crop that needs nitrogen. So whether it comes from reuse water or commercial, doesn't really matter. We still have to get a certain amount, and the groundwater doesn't distinguish between reuse water and commercial. There might be some differences. I'm not versed in how well it moves or anything. You guys maybe have more information on that, but in terms of the total amount, it won't change. So that's the point. If we take it out of reuse water, it's going to be made up by a commercial. The secondary treatment will remove that nitrogen from reuse water. It's going to convert it to nitrogen gas, which Frederick already pointed out. And then finally, nitrogen removal from reuse water and production of commercial fertilizer. Those are both going to take significant energy. So this is the diagram I was referring to. I know the text is small, but just on the left-hand side, here's what we will be doing with secondary treatment. So the projection we had, I think this is based on some of the ports numbers, is 16 million kilowatt hours of electricity to operate that secondary treatment system. That'll be taking all that nitrogen and off-gassing it to N2. Now, okay, yeah, you're right. That nitrogen leaving will no longer go in the form of organic nitrogen and ammonia, variable nitrate, and ammonia will no longer go to the farm. So instead, we still have to make up, this crop still needs the same amount of nitrogen no matter where it comes from. So instead, nitrogen gas is going to be pulled in from the atmosphere in a commercial fertilizer plant. They're going to, but the Haber-Bosch process is going to be used to convert that to ammonium. And that 1.5 million pounds of nitrogen fertilizer is going to require 6 million to 8 million kilowatt hours of electricity. It's going to be converted back into urea or ammonium, and then land applied in the same thing. And so the total energy cost to remove all that nitrogen, take that gas somewhere else in the world, convert it back into fertilizer, and then land apply is equivalent to about 2,150 homes per year. And part of what I've been trying to get at is that these inefficiencies don't just represent a cost in terms of, well, yeah, the farmers are going to pay money for that commercial fertilizer. It's also the carbon impact of now we have to go somewhere else and buy that has all these other things that we're not quantifying right. We're not quantifying what the environmental impacts upstream. And my real concern is that at the end of the day, that same amount will still be applied. And we will still have the same discussion with DEQ, with the partners online who are concerned about groundwater protection, anyone else here. We won't be able to resolve this issue, even if we do all this up here. That's what I'm worried about, is I'm worried about that we won't, that treatment won't necessarily translate into a concurrence that now we have cleaned up groundwater. So that's kind of the cost there. I will say, and I appreciate everyone highlighting with Justin, Consor, highlighting that treatment does provide flexibility. And that's why I was trying to distinguish between nitrogen treatment versus like BOD, TSS, some of these other things that we need to do, but where that nitrogen limit is, I think what I'm trying to highlight right here. So the next piece of this is the secondary treatment won't solve agronomic rates. And again, for everyone, agronomic rate is simply, well, we'll disagree on what the way we, so I think farmers, you guys would say agronomic rate is the amount that we apply relative to what the crop needs, right? So it's essentially, it's a medicine. We say, you're my patient. I think you need this much to be healthy. Here's your prescription dose for your agronomic rate. DEQ, Justin, I think the way you define it as, we tell you what a maximum threshold of nitrogen that can be applied to a given crop. And the assumption there is that anything above that would be protective of groundwater. So it's effectively a best management practice or a ceiling limit, and you can work with anything below it, but not above that. So with that, we have to agree on how much, what that should be set at. Is it 100 pounds? Is it 120 pounds? What I was trying to get at earlier is a small change in from 100 pounds to 130 pounds might have a big impact on how Jake operates his farm and what he's able to produce. What I was concerned, and Justin, I think you had a great response on this, which is, my concern is, can we measure that change? Can we say, okay, we reduced it from 130 down to 100 to be protected of groundwater? Are we able to look at groundwater data and say, yep, there, we saw it go down? So I'll leave that open. I think there's probably a lot of feedback feedback on whether that's true or not, so leave there, but the point here is that what comes out of the Port of Morrow, that aerodynamic rate is made up of all the nitrogen that is land applied, so it's gonna come out from organic nitrogen, ammonium, and nitrate. And in the port water right now, it's, if you look at a full drop, you've got less than 1% is nitrate, which is the most mobile form to groundwater. You've got 80%, which is ammonium, ammonia, which is very plant available. And then the last 20% is organic nitrogen. The reason this is an issue, Vern brought it up earlier, the way we've gone back and forth, so, and Justin, you'll remember this, the permit used to say that 20% of this, 70% of this whole drop is counted in loading. So to be compliant, we say, you tell me, you measure this, there's 100 pounds of it, only 70% of that actually is accounted towards loading, because once it hits the field, there's all these other processes that determine whether that's actually available. Like, does the plant actually see that 100 pounds? And I think Vern and Jake and Craig, what you guys would say, well, I applied 100 pounds, but I only saw 70 pounds worth of yield, or it only looks like the crop responded to 70. Now it's or 20, you know, so now the permit requires 100%. And so the reason I'm bringing this up is that even if, this is my first point, disagreement on the method to calculate, even if the treatment system removes it to a certain level, there's still disagreement between, and I think just in the science, not from DEQ, farmers, and just maybe the academic community on, when we apply that 100 pounds of nitrogen from the treatment system, how much of it is actually plant available or not? And if we can't agree on that, then it's hard to set a benchmark of how high it should be. And therefore, it's hard to now calculate what the treatment target should be from the water treatment system, because we don't know how much is actually the plants across the whole program can take up. So this is something we're working on right now. Justin brought up, we're working on pilot studies where we're submitting formal plans. Jake will tweak 10 or 30 pounds of nitrogen. Then we have all the sampling that takes place. So we are working towards that. But my point is just that when we're talking about, you know, Consor asking these questions about capacity, there's a couple other downstream things we have to solve, because otherwise it's hard to justify or quantify what the effort needs to be. And then I already brought this up, but just to me, it seems like it's unclear how the permit required monitoring, meaning soil sampling, tissue, and others can be used to evaluate how effective those current agronomic rates are. And what I was getting at there is, again, if we change it from 100 to 130, the pilot studies, Justin, I agree, are great. I think they're the best path forward we have right now. But I do still think, you know, Kelly, when I'm hearing concerns, it's still just the matter of collecting data and how fine that data, what that data is able to tell you about reality, about what's happening in the world. To me, it's difficult to measure a change from 10 to 30. That 10 to 30 has such a big impact on farmers. But to me, it seems like it's very difficult to see that in groundwater data in a meaningful way to adjust our response. So again, I don't have a solution for that. I'm just saying, to me, that seems like we might be talking past each other sometimes in that respect. And then here, the last part of that is, if we don't agree on that, it's going to be really hard to incentivize people to stay in that program when they can just simply leave and then not have any of those, which is the reuse water concern we had before. And if that's the case, in that acreage that's currently in the reuse program, people just stop being part of the program, they leave, they go outside of the jurisdiction, and now they don't have any of these agronomic rates or caps.
So if there's X pounds of nitrogen in the water, but we say only so much is available for the crop, how can the commission be confident that the rest of that nitrogen is, in that case, potentially quote unquote unaccounted for? How can the commission, how can the process be confident that we're not losing containment, or that we're not losing that nitrogen that's going somewhere? Where does it go, the unaccounted for nitrogen, and how do we keep it in the root zone?
Sorry, I got distracted by you said that.
So if they say there's 100 units of nitrogen coming out of the wastewater, and we say there's only 30 available for the crop, so in theory, there's balance there. There's 70 pounds of nitrogen somewhere in the system. How can the commission and how can the stakeholders be confident that the system is not losing containment of that, or it's not implied that it's going down into the groundwater? Where does it go, and how do we track it?
Well, right now we do soil sampling. We look at tissue samples to see how much nitrogen is removed by the crop. And we monitor soil moisture to make sure that it's not lost below the root zone.
So if it's not moving down and it becomes available later on, we pick it up in the soil sample to make sure that we're maintaining.
This is a rhetorical question.
What?
This is a rhetorical question.
No.
Oh, yeah, no, I mean,
This is the issue.
Yeah, so there's a couple of things that happen, some volatilizes, some mineral or denitrifies. And what you find is what's left over, that's the real number.
No, it's not, I'm not trying to lead anywhere, I'm not, but this is the fundamental understanding of the current system and it approximately the entire.
Otherwise, we're not dealing with reality, it's imaginary.
What's that?
I said, if we don't figure this out, we're not dealing with reality, we're talking about imaginary things that are not true. You know, and those are assumptions that this whole thing is based on.
Well, then we're gonna get distracted from the things that we really can do to fix the groundwater. We're chasing the ghost on these things, when there are other things we can do to make a real impact on improving.
Yeah, so, and I came up with this analogy probably because I was driving, so I thought of highway, so. It's not perfect, but I'll try the best here, so, and Justin, feel free to correct me if you think this, like kind of the idea of, how deep you would apply this matches the analogy, but the way I see it is, you know, the Guam, like the groundwater can be thought of a bunch of different types of roads. And DEQ has been given the responsibility of protecting public health on those roads. And the only tool that they have, they've noticed that there's been more incidents, there's wrecks, and they need to do something, but the only tool they have is just to simply push a button and everyone's brakes. It pushes the brakes on everyone's cars. Right, and so that's their tool. They have, in this case, what that brakes represents is they ratchet down aerodynamic brakes. If we limit how much people apply, then nitrogen goes down and groundwater improves. Okay, so that's the tool. That's what they don't really have another tool in their toolkit at this moment. But what happens? So you've got some roads, and the problem is we don't agree on what the speed limit should be. And so you got Jake driving 45 miles an hour. Well, actually, you got someone else driving 110 miles an hour, and DEQ is like, someone's gonna get hurt, they hit the brakes. Everyone says, okay, great, we reduced the 110 down, that's good. But the brakes also got hit for Jake, and Jake was driving 45, and now Jake's driving 20. And he says, what the heck, you guys? Well, what happens when you keep doing that? Now there's a traffic jam. And not only do we disagree on what the speed limit should be, i.e. the aerodynamic rating, we also disagree if we're driving in a kid zone by a school or we're on a highway. And those represent different crops. Some crops are going to be very sensitive to nitrogen and have more potential to leach the groundwater and impact groundwater. Other crops like alfalfa, those are our protection crops. Those don't have as much. There's still limits, right? Well, I don't think, farmers, you can correct this now, but I don't think we agree on what the speed limit is. And depending on where you're at in the Guam, we don't agree on whether we're driving in a kid zone or we're driving on the highway. And so what's happening is we've got one tool to help protect groundwater, which is constantly hit the brakes, hit the brakes, hit the brakes. Everyone's getting slowed down. There's no discrimination in terms of providing flexibility here, but you need to slow down here. And so you get a traffic jam. Well, what do people do in a traffic jam? They take another route. They say, I'm done with this route. I'm not going to drive anymore. I'm going to take another route. And once they get off that route, now there's no brakes to hit. And now everyone's back to square one, unregulated and no ability to rein in nitrogen. That's why I was asking questions about upgrading nitrogen coming to the port's property, because to me, it's hard for me to help the port make a management decision that can protect groundwater if I can't distinguish how one action benefits or doesn't benefit relative to what's going on in the background, right?
It's a great analogy. The only thing I would tweak on the analogy is that not only you're slowing people down for current speed, you're slowing people down from potential speeding that may have occurred 50 years ago. And since it may have occurred 50 years ago, you're saying the current system needs to slow down because of the results that we're seeing from stuff that happened a long time ago.
And to be clear, with all that said, I don't want there to be accidents. Right? That's what I'm getting at, is we can all agree on, we don't want people to have accidents, we want to decrease the frequency of impact to groundwater. The question is what is the tools and the mechanisms we use to get there, and that's what I'm trying to have. So one thing I want to bring up, and Justin, I don't know if you guys have been tracking this quite a bit, but House Bill 2169, this is recent. They're looking at Department of Environmental Quality, the support from water reuse team where appropriate, and in consultation with municipal wastewater utilities, industry stakeholders, and other interested parties shall evaluate environmentally protective approaches that have been successfully employed by other state water reuse programs and that may be appropriate for water reuse in the state. So they're looking at it right now, it's basically reviewing the program, what makes sense. And like I said, and just when I'm using the break analogy, this is not to be critical. If part of it is, my understanding is that DQ is very limited because we're trying to protect groundwater. There's certain things we might not be able to look holistically under law for that. Again, I might be oversimplifying this, but hopefully through some of this review, we can increase the toolkit for them in a way that makes it more flexible for them to manage this and actually see groundwater improvement. So what Lauren and I have done is looked at some other states. We work in other states on these reuse programs. So for example, Washington does not set ceiling limits for nitrogen. Like they don't have a concentrator not rate. What they do is they evaluate the nitrogen balance. They consider the negative or near negative nitrogen balance to be compliant with economic rates. They take into consider things that we don't, which is like volatilization, denitrification, and they don't start with the original starting soil nitrogen. So that's an interesting, that's something that different than we do. And they use post-harvest soil tests as field report cards, where fields with increased nitrogen at the end of the year must be planted to a higher uptake crop during the next crop cycle. For example, down here, where fields show an increase in soil nitrogen utilized at the end of the year, the city schedules alfalfa to be rotated into utilize excess nitrogen. So this is from Pasco's industrial city, which some of you guys were mentioning. They've just had a new reuse water program start because of contaminated groundwater. And the funny thing about this is stuff we already do, right? So we switch to a higher crop. It's more whether we're determined to be in compliance or not. So that's Washington, our neighbor, and then in Idaho, is it going or is it just?
It might be dead.
Another one here in Idaho, they don't set ceiling limits for nitrogen. The general nitrogen loading rates are 150% of the expected uptake, and they don't cover nitrogen in the soil. So they cite crop-specific loading rates that can be calculated, from an EPA method. And then I think Lauren, correct me if I'm wrong, but so that 150% crop uptake is based on a 3-year moving average. So they'll say, okay, based on 2018, 2019, 2020, the amount of nitrogen you can apply in 2021 is the average of those three. And why that's important, Jake, I think this might help, would be when you say you switch to a new yield, well, or it's a new yield, a new variety or hybrid or something, and you start seeing increased yield, DEQ, being wanting to be protected, would say, okay, now you can jump up your economic rate. What you would do is you'd say, well, over 3 years, that average will start to go up. And then it provides a continuous feedback loop for both. Lets you move to a new crop and let DEQ get feedback response to show that we're not having excessive nitrogen losses. So my point is there's some technical approaches here, I think, that might be able to be included that could help resolve these. I'm not saying any of these are silver bullet, or we should just adopt in other states. I'm just saying with DEQ relooking at their program, I think there's an opportunity for a lot of input to see what works, what's protective of the environment, and what can be managed at the field level more effectively. And to wrap things up, we still want to talk about the slide because we've already been there, but I want to come full circle with consort. Are they still? This chart, what I'm trying to show here, Laura and I took 2022 to 2023 farm data. So we took all the different crop rotations and looked at what the agronomic rates were, meaning how much nitrogen would be needed to supply to all those crops. And we tried to calculate what the concentration of total nitrogen in the wastewater would have to be so that the port could just use reuse water exclusively, like no fresh water. So we're able to hydraulically meet the crop demands and not exceed an agronomic rate. Now, there's an issue with this, and I'll just say it before I get here, Jake pointed this out to me. We can't think of the crop system as like we can continuously supply water and nitrogen the whole time, because a lot of the nitrogen happens at certain specific times. Anyone's a farmer knows this. It's more like an Amazon delivery system, where in March, April, or whenever the time permits, you get packets. You need to deliver packages of nitrogen and water out there. Then you need water for the dry season. Like you're going to need a lot of water the rest of the year, but the nitrogen is sometimes packets. And what we need to make sure is that the nitrogen in the water is low enough so that you can put that water out there and meet the hydraulic demand, but you still need to send packets of nitrogen out every once in a while. The little Amazon packages, right? So all that to say is, this was just to show proof of concept. Do we want a 7 milligram per liter treatment? So we took all those fields, and here's the percentage of those fields. And this is plotted against the target nitrogen in the reuse water. What it's showing is that, for example, if we target a nitrogen concentration of reuse water of 7 milligrams per liter, let's say all year round, that would mean that 98% of the fields in the port's program could use reuse water exclusively with no fresh water. Right, so it's basically saying you can just unlimited use it, notwithstanding what I just said about the limitations of this. But as Justin pointed out earlier, that's the 7 milligrams per liter is only for the non-root season. So if the purpose of the treatment is just holistically, we need to manage our nitrogen well and set it when it needs to be sent and not over apply and have an impact on groundwater. Can we look at one of these other numbers? And so at, for example, 30 milligrams per liter, you've got 64% of the fields in the program fall below that. So that means 64% of your farm, your acres, could be land applied 100% with reuse water, and the other 36% might need to be finished. Now, it doesn't mean it all has to be fresh water. It might mean it just needs 1 more gallon of fresh water. We didn't look at like how much more, but it's just saying, I think somewhere in here, there's a level of protection that puts us in line with permit compliance and protecting groundwater, but also hopefully reducing the cost of secondary treatment. Now, I made this before I asked all those questions to Jacob and Conser, your team, and the reason I was asking about flexibility is what I'm hearing from you guys, I think, is that the secondary treatment system can be built to be able to operate down to 7. But if you dial back your oxygen, let that BOD go from 20 up to, let's say, 100 or 500, whatever the farmers say we need, and nitrogen doesn't need to be down to 7, it needs to be at 30 based on compliance with economic rates, there might be some OpEx savings, but maybe not capital. So I'll leave it there, and then any other questions, but I would just say that you guys have also changed my opinion when I walked in the door, so. It's kind of so.
Yep. I'm here. Can you repeat the question, please?
Well, I was just saying, I think I gathered from the questions earlier, in the last chart that I shared, I was trying to highlight that, that nitrogen target and potentially the BOD target could be movable, but I think what I heard from you guys is the technology wouldn't change and the size and CapEx wouldn't change, but potentially the OpEx and what you operate that to remove down to could be adjusted.
Yeah, that's correct. It would be less air, less chemicals, less OpEx, but the same hydraulic footprint, if you will, to be able to pass those flows.
And so a question for Jake and Craig, I guess, that the practicality of using effluent water all year really isn't, it's not practical. It's
unless you're growing alfalfa, from that standpoint. Everything else, we try to work really hard. That's why we have the diverse crop rotation we have, is to match up the crop needs with the fertility needs and the water needs, so that we've got something all season long that's gonna be using reuse water from that standpoint. So we technically are applying it all season long now, just not on every acre, and we're just balancing that rotation in those acres out to ensure that we get consumed what we need to get consumed.
Right.
So,
You couldn't, on your corn, you couldn't put full power fluent water on the corn all year long, because you'd be over
correct.
your ag.
Yeah, right, and it's important, kind of one of the things that we've been trying to operate by is, you know, the difference between a good farmer and a bad farmer is 2 days, right? I mean, they do the exact same thing, but if one of them's 2 days late, he's not gonna get the same results as the guy who got stuff done on time. So, with that in mind, your nitrogen needs for your corn are kind of on the front half, so to speak. And by then, it's taken up a little bit that's left in the soil, and then it's using what it's already taken up and built into it. So from that standpoint, applying more nitrogen through reuse water after a certain point is detrimental. We purposely didn't do that on a few trials. We had some trials approved last year to test some agronomic rates. But by the time that we got them approved, we were outside the window where we would have seen a yield result. And so we ended up not doing it, because what I didn't want to do was go apply that reuse water later than when the absolute most beneficial need was. And then have it come back with a high post-harvest soil test, and then have to explain what happened, you know, to DEQ. And so we just pulled the plug on the whole thing. And so we're trying some of those trials again, trying to get the timing down on the front end to get it right. It's the trial process is proving effective. It's frustrating, but proving effective. But we're making sure that we're doing it right, you know, from that standpoint. So, you know, and DEQ has been working with us on it. We're gonna find out, you know, on the canola, they approved a 280 pound rate this last year for a trial. That was an increase over the 250. You know, we put very, very little commercial fertilizer on that. So, you know, if we don't see the yield response that we were expecting to see, it'll support the theory that we're not getting everything out of this water that we think we are. So from that standpoint, you know, there's a lot of stuff kind of that we're talking about all the time. So.
And I think it's an important clarification to follow up on your point about water, you know, putting it on year round, because there's two phrases that really, so I grew up on a dryland wheat farm with my wife, and I currently farm. And so, you know, I spent my entire life, both from the irrigated perspective and the dryland perspective, both praying and begging for water. So the terms that are used in here, like dispose of and you know, the non-growing season, are just such a misrepresentation, just a gross misrepresentation. Because unless, I mean, it's not optimal to put water on frozen ground, no doubt. But growing up in the dryland, I mean, I wanted the snow, I wanted every drop that came on there. And sometimes, you know, the snow would melt, the ground got frozen and run off, you know, and you certainly don't want that. So, you know, from an irrigation perspective, you just, you know, applying to frozen ground is not ideal, no doubt. So getting rid of that, it's a nice +1 for the system. But there are times in November, or even February, that if we have an open winter and the wind starts blowing here, Morrow County blows into Umatilla County, and Umatilla County blows into, you know, LaGrande, and you want to be able to put that water on. And you want to be able to store that water. You know, I mean, there's no such thing as applying bad water to the desert, as long as you're not losing containment of it. And even on the dryland stuff, we monitor our soil samples down, our fertility and soil samples down 5 feet deep. And we do it differently closer to waterways, you know, and that's practices that are just inherent in modern ag. But there's not a scenario under which inside the current permit parameters that and even in the last, you know, Shake's been putting port water on since what, 2015, 16, that there's been a disposal of water. I mean, there's no such thing in the desert. And you can store, it's a proven practice in all of agriculture, whether it's pasture, whether it's dryland wheat, you store fertility and you store water in that soil profile as a beneficial application for the crop that may or may not be planted. And so I understand the whole point is to maintain that containment. But can we put effluent water on all year round? No, that's why it takes fresh water to go along with the reuse water, so the fresh water can grow the crop and keep the crop healthy, that nutrient will feed, maximize yield and maximize the uptake of the fertility. That's a super important concept, because disposal is a misnomer. We are not disposing of an industrial waste from the Port of Morrow. It is water that has some macronutrients into it. That's why I tipped over earlier on the concept of you take the solids out and all of a sudden it's an ag exempt sustainable practice. Because we believe that that is what the piece of the French fry that you cut out that then gets repurposed as a tater tot. That's what we're doing. That's what we're doing with the water from the port. And so that's a really important follow-up to your comment about you couldn't put it on all year. No, you can't put nitrogen on all year. You know, but if monitoring and keeping track of that water, there's just no such thing as a bad application of water in the desert.
Yeah. Is there any other questions for Joe or Lauren for parametrics?
No, thank you.
Okay, well, we'll move on to anything else you got, Jake? Greg?
It's totally up to you guys. I mean, everything that I was gonna present on has been sufficiently covered or discussed. It's, I mean, if you guys wanna look at the slides that. Stuff, you guys.
I think so.
Okay.
Some of those that were too small to read.
Okay.
I can give Jay our way to
It's what popped in my mind.
It was helpful.
We don't have any.
Okay, so, the goal of this today is to continue the discussion that we had last week, so we're gonna dive in a little bit deeper and the differences between reuse farms, non-reuse farms, what the yield goals look like, and then talk about economic rates, that kind of stuff, and if we want to, if we have time, we can dive into the model that we built that shows, you know, what we can consume, and that you guys still have a ton of growth potential. There you go, I just said all that. So we're gonna go with the basic crop.
Jake?
Yeah.
Before you start, just a time check for everyone. I don't know what your end time is. Mine, I've got a meeting at 12:30, but if you're still talking, I can just take care of that.
This has been very informative. Yeah.
Good. So we're gonna just go through and we're gonna look at the effects of nitrogen limits. We're gonna talk about comparing that traditional crop rotation to a reuse crop rotation. And then modeling economics of and reuse capacity. And then hopefully have some more questions, discussions, same as last time. Stop me if you got a question. So things that go into the basics kind of crop budgeting, right? When we put this together, and this, you guys had a lot of questions about budgets last year or last 2 weeks ago, so I wanted to go through this. So these are all the inputs that that go into budgets, right? And kind of what they are. You've got crop nutrition, which is your fertility and the application process. You've got crop protection, which is the pesticides, herbicides, fungicides, you know, that kind of stuff, things that protect plant health and the application cost. You've got seed and irrigation, so you've got the cost of obviously the seed, and then the pumping cost, irrigation district O&M cost, water leases, all that kind of stuff. So that's all factored into the irrigation numbers. Field operations, tillage, planting, harvest, transport, repairs on some of that equipment, road maintenance to be able to get things in and out. The amount of traffic that's on these reuse farms now is absolutely insane. From the standpoint of what's being required from a monitoring standpoint, you know, a port vehicle or an IRZ vehicle or construction vehicle or something. So, the management overhead is office staff, plant staff, crop monitoring. And then the land piece, so the land rent, so every farm in the region charges themselves land rent, and that covers debt service for land purchases, that covers development costs, and it covers basically all your long-term loans and stuff like that, so. You guys own a farm now, and you guys are gonna be getting paid land rent on that, so, you know, from that standpoint, that's That's an important part in any cropping system budget. So these are some of the effects of the DEQ. Hope you guys can read that better this time, right? A little bigger. Yeah. So there's two crops on here. There's corn and wheat, and so you can see the yield projections for reuse. Last year we averaged 6.2 tons on the reused corn. I think we can do a few things a little better and get that up a little bit. On our non-reused acres, we were able to exceed 8 tons. So from that standpoint, there is a cost difference. You can see the sale prices per unit is the same. The gross revenue is significantly different. The additional expenses are additional fertilizer and additional water and additional freight. But you can see the variance is $157 an acre between where we're at today with the current agronomic rate versus what would be an appropriate agronomic rate.
Do you see any difference in post-harvest soil samples on the bigger yield?
Yeah, the bigger yielding fields typically are. They're bigger, the plants are taller, they're bigger, healthier, you know, so they have a more robust root system. And when you start to stress a plant, the first things that start to really get weak are the root system.
So when you said cleaner, you mean that the soil has less nitrogen?
Correct. Yes.
Yeah, good point, thanks.
Yeah, no, that's a good point. So there was less residual nitrogen in the soil and at all the levels, allowing for more application space moving forward.
Jake, how do you determine yield just from nitrogen? How do you know your yield isn't your 2-day great farmer? I missed my 2 days. I put my fertilizer on. I didn't get.
Try to make that up where like we're doing it on wheat today. We know that it's rained enough that we can't go put all the fertilizer on that we need with reuse right now. So we're pumping some commercial on. And so it is very situationally dependent.
So do you factor in other things that farmers go through, pests and?
So we do, and on that, it's factored into both the same from that standpoint. So the 2-day thing, we try to be on time on all scenarios. It's not like we say, we're gonna be late on this scenario, it doesn't matter. They all matter. And so, you know, if we do have a weather event or, you know, something like that, that affects all of them the same. It's a good question. Same thing, our average last year was 135 on some non-reuse fields. It's pretty easy to hit 160 bushels with appropriate timing on stuff. You see the price per unit difference under the current agronomic rates for hard red winter wheat. We talked about this last time. There's a protein discount for low protein. So that price difference is what we saw last year between low protein deducts versus what we wouldn't have been deducted if we had the appropriate amount of nitrogen or protein level.
So you're saying winter wheat is you need more than the 160?
So no, yeah, I mean, right now in the current market, yeah, on all of these, it's bad, whether it's a reuse farm or not, but the difference is the variance, right, between the reuse farm and not. So the interesting part is when you get to the next slide and start talking about alfalfa, the difference between a reuse farm and a non-reuse farm. A non-reuse farm isn't gonna grow alfalfa. So we won't, I mean, they wouldn't have to do alfalfa. They'll have a different crop rotation, which we have up here also talk about that too.
Most traditional crop rotations on full water farms will be wheat in the rotation. I mean, there's a special case, there's a couple farms in the area that use it, but they're on a tighter potato rotation.
If you went potatoes, onions, peas, wheat corn, grass seed, you know, in a rotation, you wouldn't have any of these there. Same thing with alfalfa, and canola, right? From that standpoint, alfalfa has a pretty high structure cost to it. And under the current market, I would argue right now, I can't even sell it for $147 an acre, but, that's the loss on alfalfa. Again, we'll talk about where we're at on difference between a reuse farm and a non-reuse farm. We don't see a yield drag one way or the other than a non-reuse farm wouldn't have it. Canola, you know, reuse, we've got 3,700 in there. Non-reuse, we've got 4,500. Same prices, same production cost, with the exception of fertility and water adjustments. And it's $110 an acre. So that kind of stuff just continues to add up and takes fun of it. And it's a big economic deal. By the time you take that, it's $109 an acre. Doesn't sound like a lot. 367 sounds like a lot. But you take any of those and divide them out here, multiply those out across the acres that have to be in the program to be able to consume this, and it does come up with a pretty big number. So the difference in economic value from port or to industry or to me, between appropriate economic rates and not appropriate economic rates is a big deal. I mean, it has a significant difference. So this is a traditional, land rent on the top. So first crops, potatoes, ryegrass, onions, corn, pea, sweet corn, we put together a 5-year rotation. You can see the land rent that each of those would pay. And then you can see the net income on all of those. And so if you go through and look, on a 5-year, you average, between land rent and net income, you average $1100. You go to and again, we just use the solid 200. You guys saw the numbers on the last couple of slides, but what these crops are able to pay on this crop rotation of alfalfa for 3 years than wheat, than corn. They pay $300 an acre and are still not profitable. So the difference per acre on a solid reuse farm that's being maximized to consume reuse water versus a farm that is, fully irrigated and doesn't have to grow alfalfa and wheat, but also doesn't have the agriculture. And so part of the reason why we don't grow more alfalfa or more bluegrass or potatoes or onions on the reuse ground, there's room for it. We can't achieve the yields to be economic because of the agronomic rate restrictions.
So it's a double whammy, because not only are you taking more marginal crops and you're taking yield out of more marginal crops, you need more acres of marginal crops because you are agronomically rate limited, and so you can't have the high value crops in the rotation. So it really hits you both ways. And historically, I think it's important to know 2 things about the history. Because Kelly, you had a valid point last meeting. Why are you doing it? Why? So when we first started when Jake first started doing this, and Jake's had reuse on the farm for quite a while with Glen Weston, Hermiston. And the way that the permit used to work is that you could have a rotation. There was a potato rotation because it wasn't agronomic. It still had all the requirements on monitoring the soils, but you could grow what you needed to grow. You weren't limited to some arbitrary nitrogen rate. Okay, so you could have a more traditional rotation. And the second thing for Jake is the farm has been water short. When the farm was first developed, it didn't have the ability to grow full water crops on all the farms. So over time, Jake's been able to add to the water profile on the farm, to where the farm so he was getting 2 things with the reuse. He was getting acre feet of water and he was getting fertility. And that fertility helped make the rotation crops viable. Now, the rotation crops aren't viable anymore because they're rate limited, so we can't get the yields that we need. And 2, we've gotten additional water on the farm. And so when the water requirement isn't as big as it used to be. And so to another one of your points, Kelly, is fresh water worth something? Absolutely it is. It's what I've spent most of my career trying to bring additional water to the area. But it's not. The reuse program, pre-15, post-15, literally went to the other side of the balance sheet, from an asset to a liability. When you were rate limited, not only did it limit your ability to yield, it limited your ability to maximize your crop rotation. And it has turned the reuse out of agronomic rate, has turned the reuse into a liability. So why would we continue to do it? So that people don't lose their jobs. And because we believe that is the most sustainable way to apply this fertility, and it is.
There's another component to the economic picture of the ag cycles. Now, these are historically low prices for alfalfa, wheat, corn. The cowboys are the only ones that are doing anything.
Finally.
That was long time ago. That's another significant piece of this thing. If it's $200 hay, the balance sheet looks a little different.
Yeah. And that's what we ran into last fall, is that it was a full stop. The banks, it just was not viable anymore. And you couple that with legal troubles And that's why we had to do the full stop, not because we were playing chicken, but because we got told no.
Here's a question I have on the reuse acres. Do you have less fertilizer cost?
Yeah, and you saw that in the cost analysis, when you looked at the cost per acre, they were less. Yeah. Yep, and so two things on the reuse acres, less water costs, because obviously it's water, and less reuse costs, or less fertility costs. Yeah.
Yeah, when you can grow when you need to yield wise, you get the acre feed and the fertility. I mean, it's an asset, no doubt. I mean, no doubt.
And that's the emphasis on, that we put on, last week, or 2 weeks ago, and today, as far as, we need to truly understand what's in the water, so we can appropriately account for it, and understand the fate of it, that kind of stuff, and I think, to Joe's point earlier, that's step one, because that'll dictate really hard and fast which way you go, from that standpoint, and I think it has to be done in DEQ, it has, and we've got to get buy-in from everybody, and say, okay, we agree that this is what this water is, and this is how we're gonna account for it, and then we can move forward and pick the appropriate path. And maybe it is secondary treatment. I'm not here to say one way or the other. I'm saying the system you have in place now is capable of consuming what you need it to for a lesser cost. Financially, I don't know what the other costs are. We can do it safely. From that standpoint, the acre base that's there is built, it's big. Put a big acre base together. And it'll do what you need it to from a consumption standpoint. The political standpoint and the business standpoint of it are two separate things from so. You open the Excel. You can compare that, please. Quick. Kind of really quick, kind of dirty walkthrough, and if you want to change the numbers, we can change it, but I tried to build 2 or 3 different scenarios, kind of what you guys can see, and so this is system wide, this is not just farms that I'm farming on my farm, right, so this includes farm 1, farm 3, farm, all that kind of stuff. All right, they're not going to see that, so can you zoom in a little bit enough, please? That's pretty close. I don't know if you guys can read that, but no. Okay. So this is a model that shows 13,100 acres in your system, which is roughly what you have. And that's 3,500 acres of alfalfa, 500 acres of buckwheat, 800 acres of canola, 3,500 acres of corn, 3,500 acres of hardwood winter wheat, 1,000 acres of triticale, and 1,800 acres that don't get any reuse. I wanted to build some safety buffers into this, and hopefully have some cropping flexibility changes if we can get some agronomic rates fixed. So what I did is I came in, where's your ruler? Green. Okay. So I came in and took an average starting soil test across our farm this last year. It was about 85 pounds was our average. So then I came in and I said, okay, I know I'm going to need to apply some commercial fertilizer to these fields to get the timing right of when it's most beneficial to the plants. And so this left a reused pounds available, for each of those acres. So I took the total reused pounds, so the pounds per acre times the acres gives you total pounds. So this is projecting about 3 million pounds worth of consumption. I converted that to gallons, which is 3.7 million. I added a 10% buffer factor in, so we're accounting for 90% of it, and it works out to 3.3 million gallons that we can consume. That's 1% over the 2026 budgeted projection. That's it. It's 11% over your 2023 capacity. So, and what that does, if you scroll right there, stop. So what I did is I put some economics associated with that, so we can see what the different things look like. So this is with current agronomic rates and current 100% TPA accounting. And so these are yields here under this scenario. These yields are the same all the way across. So you're 8 tons for alfalfa, 3,800 pounds for canola, 7 tons for corn, 135 bushels per week. And so then the only thing that changes going across here is pricing. So you've got poor economic pricing, average economic pricing, and exceptional economic pricing. So it's 230 tons for $30 a ton for hay and corn, $8.50 per week, and you kind of see how the payments, what the loss is there from poor to making money. Right, from that standpoint, we can lose money to making money based on pricing and then also on economic rates.
Can you read those prices off for the poor average, et cetera?
So for poor economic crop conditions right now, I got alfalfa at $140 a ton, canola at 20 cents, buckwheat at 20 cents, corn at $180, which I think today the bid I saw was like 186 or 187.
Sorry, I mean the total net, just so, because I don't know if everyone can see the 5.7.
Okay, so the total net loss system wide on that crop rotation would be $5.7 million. Average pricing is 3.2 and exceptional pricing is 8.14 with, 841,000 with a large percentage of that coming from your dealer. Because that price doesn't change much at all. So if you go then back to the left all the way and then down one more model. Okay, so this is exact same acreages with the, it's not because I didn't need to. I tried to achieve the exact same consumption from that standpoint. So this is with appropriate economic rates, but still accounting for 100% TPN. And so what we found was we could reduce the number of acres of alfalfa and corn and wheat that we needed to. It increased the acres that didn't need to get reuse water on. We still consume the same amount of water. And if you go to the right, the economic model shows you do 5.7 in the worst case scenario to 4.1. And that was purely, so we saved $1.7 million worth of loss, so to speak, just purely by producing more product per acre. And then the average price resulted in 1.7, and the exceptional pricing was, we were able to get rid of triticale also in that model, because we could consume the gallons on more profitable crops. And so there was zero payment due there, zero loss. So I got one more. I think, there you go, okay. So this is same base agronomic rates, but adjusted to what we used to have as a 70% TPN number. And again, that number can fluctuate, right? Whether, whatever, hopefully we get a chance to really study, we can plug in what that number really is. I went to 70% because that's what was previously approved.
Jake, that was 2015.
It was approved all the way up until 20.
70% was?
Yeah. Yeah. And then, yeah. And so what we found is we could consume way more than we needed to from that standpoint. If we get this right, which gives you, under this particular model, that's 2,900 acres not getting any reuse water. So, I mean, there's a big buffer there. And that gave you the capacity to exceed our 2026 projection by 36% and your 2023 levels by 50%. And so if you want, we can play with that in a minute. Well, we can maximize that out and you can see kind of what that does to stuff. But there's a scenario here where you can double your capacity on farm ground and make it work. So if you go to the right again, you'll see the yield numbers have changed because of the more accurate counting of what we've been seeing on the farm. You know, we don't believe that it is 100% of the TKN that's available. So if we can get to the 70%, you know, we'll go back to what we've seen historically yield wise as far as some better yields. And you look at some pricing on that. And under incredibly poor economic conditions, you're at 3.3 now. We started at 5.7. So that's a very significant savings. Average pricing, you're at 1.3. And exceptional pricing again is profitable. So when you look at it from the standpoint of what does the cost of that mean to industry or, you know, to the customer base, that's why I have this 25 cents. That would be the cost per 1,000 gallons. So when you're comparing options as far as what path you want to take, having something, you know, to put the farming side of things in perspective on what the cost per 1,000 is, because that's how you guys are going to get invoiced industry and everything else, right? So I wanted to try to convert that back where we're talking apples to apples when we go to look at your other costs.
What happens to the non-reuse acres on a yearly basis? So is that conventional farming then?
No, so there's still, so the non-reuse acres are what we're calling acres that don't get reused water. So they could be, I mean, whatever we could find that would fit under an agronomic rate, because right now, that's why there isn't, like on our farm, there's no acres that don't get reused water. Because, you know, we have some major discrepancies on some of the agronomic rates to the point where, you know, like for bluegrass, I didn't grow any this last year. Because we can't agree on the agronomic rate, and I've tried for years to make it work, and, you know, at the current economic, it's not economical.
So those acres are still subject to the permit, because they're not using water.
Even if they don't see a drop of reuse water all year, they're still subject to the limitations on the permit. And so that's why when Kelly was asking me, you know, well, does the water have value? Yes, water has value, but being under this permit is a massive liability as far as being able to select an appropriate crop rotation. So, and I don't know if you guys want to play with this, we can play with it if you want to change some acres and see what you can do. I mean, we can do whatever you want, but I mean, we can get to where on a lot of your acres, you can consume, and I mean, if you want to, let's say you did lose a farm, pick one. I mean, we can go play with that and see what it looks like too. So if you guys want to just move on, then we can move on,
But yeah, Jake, if when you scroll down, this is what I was trying to get at earlier about whether we agree on certain things. So in the very beginning, he showed the current allowable economic rates under the permit and 100% TKN, meaning how much do we count from the effluent do we count towards that economic rate?
Right.
And then he gave updated or a modified economic rate, but 100% of the TKN is calculated.
Yeah.
And or sorry, and then he looked at a changed agronomic rate, but 70% TKN, which is the method we used to use until just like the last year and a half.
Yeah.
So the numbers he's showing is highlight what I was getting at, which is depending on how, if we can't agree on how much is being applied and the method in the permit of how do we determine if we apply too much or too little, and the rate that allows where that amount is, then the capacity numbers that Chief is showing here are huge. I mean, this has huge, we're talking about hundreds of millions or billions of gallons of water changing capacity just on those questions. And when you look at, when you take just those operating costs, but then you try to now take Consor's design and say, is this design going to fit X future growth? Well, we're not agreeing on the legs of the stool there to make that assessment. And that's all I was trying to highlight is, it's not whether the treatment system is wrong or the technology or whatever, it's more, are we answering the right questions we need to even answer or assess that question, right?
Yep. And I think you answered this question last time, we were together, that say no change in economic rates happen. And we didn't build a secondary water treatment system, we have enough acres to handle our water plus 30%.
So go with it back to the top scenario. So right now with that crop rotation, yes. So if you wanted to go through and change some of those crop rotation numbers, it's your current agronomic rates, current TKN accounting. So if you went and put alfalfa at 4,000 acres, if you would. And then go put triticale at 2,000. There you go. I got you 26% growth over 2023, and you can continue to tweak that a little bit if you want.
How much money did you?
And how big loss?
There's more acres.
6.6
loss.
Yeah.
Yeah,
And that's not treated.
Correct, but what happened is we didn't adjust the 1,800. So I mean, because that doesn't really pencil back into the rest of the equation. So I mean, if you wanted to go zero out the 1,800, we're only 500 acres long here.
Jake, does this answer your own billing question for us about time, you know?
Yeah.
Oh, it does.
Yeah. Yeah, because the majority of the acres are on alfalfa, and so that gives us the ability on the trip in the fall and in the spring, and the harvest when we on the fall and in the spring.
So you're,
and the corn in
you
the spring.
treat that in by the percent of each crop you have in your program, you are correct. That's what you're using. Okay, I would have thought of that as the top of that.
I have a question. In your mind, why did DEQ, you said EPA, but I think it was DEQ, why did they change the TKN from the 70% to the 100? What was their reasoning?
Well, Justin's on, so he can answer this, but, and Warren, correct me on the fact sheet, but, so it used to be 70% TKN, and that was before the anaerobic digesters. After the anaerobic digesters, came online, the idea was that the organic nitrogen would convert to.
So it was pure, basically.
Yeah, and then you would have
The
the
same.
remaining amount, now we'd count 100% TKN, because the idea is that all of it's available to crops. Well, as you're showing that big raindrop, about 20% of that water is still, or nitrogen in that water is still organic nitrogen that has
So
to
it's
go through
volatile.
either volatile or, sorry, the ammonium is volatile, so actually
80%.
80%, yeah, the remaining 20% is still organic nitrogen that has to be mineralized to ammonium or nitrate. But then the other issue is 80% of that ammonium, once it hits the ground, it can volatilize, and we don't include that right now. So like we assume that 100% of that ammonium goes to the soil. And what we were pointing out is like in Washington, in other permits, usually you account for some volatilization of ammonia, like it's acceptable to do that. So that's item number one. And then I think Justin, part of this was just to be conservative that we're counting all the nitrogen going out there. But again, if you're counting that towards the economic rate, what the farmers are saying is, yeah, but if the plants aren't physically seeing that in reality, it's a calculated value, but we need to know what the crop needs to be successful and get the yields that will actually pull the nitrogen out. So, so then it switched back to 100%. There's a side tangent here, which is we put together a proposal that was in place for, was it a year or 6 months? I can't remember, where we suggested taking, instead of using 70% TKN or 100%, that we use ammonium plus nitrate. And the reason for that is the dominant form is ammonium, and that doesn't fluctuate as much. So what we said is, why don't the farmers use a 4-week moving average of ammonium plus nitrate, which is way more consistent than the TKN, which was kind of going like this. That way, DEQ has like a really like, ammonium and nitrate is way more plant available and also more likely to, if it does convert to nitrate, to be mobile to groundwater, which is what we're trying to protect against, right? So by using that, it gives the farmers more, they can plan ahead, they know how much they're gonna get, and DEQ can know, okay, it's based on the dominant forms of nitrogen, and then the idea there was that remaining 20% organic nitrogen that still has to be converted, we'll pick that up in the soil samples, right? Because they're sampling soil constantly, and so as that converts from organic nitrogen to like ammonium, the idea is we catch that in the soil. We don't want to double count it when you apply it, and then you count it again in the soil. Does that make sense?
So we make fertility decision processes, or decisions based on in-season monitoring. So, back to the precision agriculture stuff we talked about last time. On corn, we take the fall required sample, we take the spring required sample that are required by the permit, but we're taking extra samples at critical growth stages to see, okay, what's broke down, what's available, do we need to apply more, do we not? And then we're making those decisions accordingly. And there was a bunch of fields this year, in a few of the programs and even outside the programs where, we don't need to get to 350 all the time, but because there's organic matter breaking down or there's stuff happening, and so we're seeing that and making the decisions accordingly. But on a lot of them, we're seeing, I told you I was gonna put those pictures in the next presentation and I didn't, but we're seeing leaves wilting in August, not wilting, but literally turning yellow as they're cannibalizing themselves trying to fill the corn, from the lack of soil nitrogen available to it, and we can't put any more on.
So I have a question about the alfalfa. Why are we planting alfalfa when we know alfalfa is a nitrogen fixing? And are you seeing, 300 pounds left in the ground after plowing?
Consistently providing one of the cleanest post-harvest soil samples.
For the alfalfa as well?
Yeah, and so it will fix it, but it's a luxury consumer, right? So just because it is, you're 100% correct, it is a legume, and in scenarios where it's not getting artificial nitrogen, it makes its own and it does just fine. But in this process, we don't need it to make its own, so it doesn't waste the energy making its own.
So are you putting additional nitrogen on alfalfa, or are you letting it fixate
Just
its own?
That's it.
Just the reuse?
Yeah.
And Kelly, actually, I think, that's actually the preferred,
Yeah.
method.
Yeah.
For either.
If you put nitrogen on alfalfa, it doesn't want to make its own.
Oh, no, sorry, what I mean is from like a corrective, so like if you.
Yeah,
like,
that's what I was
you-
wondering, corrective measure, why would we putting a nitrogen fixing plant in the ground?
Right, but yeah, no, I think it's pretty well set up for both,
But the-
ODA and DEQ. See, those are the crops you go into SCAP to grab that nitrogen if you have too much in the soil. So like that is the correct, that is the measure used to go clean it up. They're like the remedial plant.
It's got a very aggressive, very deep taproot on it that can go down well below 5 feet.
And then
Are you having to, so your projection, price projections, are you having trouble selling that? Are you getting nitrogen loading in your alfalfa?
And I think it's because it's, you know, I don't have an issue with that, I'm afraid on from that standpoint. We're not dumping all at once, right? We're spreading it out across the whole season, so from that standpoint, we're not having any issues with that.
So that's not part of the price.
No, the price part right now is literally, the hay market is just that bad. I mean, if you wanted to go find $120, $130 hay right now, you could do it pretty easily.
He's been doing that.
Yeah. I keep joking with my uncle who has cows, and then my wife has some cows. Like, best thing you can do with hay right now is run through a cow. But, yeah. But
So, this is a general question, is there a path to meeting the WCF permit without this extreme treatment? Do you think there is a path? Do we need the sensitive treatment, secondary treatment?
I would say going back to Joe's analogy, we're doing a speed study test right now.
Yeah, okay.
so if you're gonna fill the new ponds all the way, yes. I mean, there's some level that has to be done. to Get the BOD out.
Right.
Right. One cost analysis, and it seems asinine, is on your new farm, there's a very large area that's flat, that was supposed to hold cattle, that does not and will not ever have cattle on it. You could go build a 200-acre, 30-foot deep pond. And you could store that water there and then only fill these ponds half full and make them the last ones filled, and yeah, it sucks that we spent the money we did on building those deep ponds, but is it cheaper to go build a 200-acre flat pond that doesn't require treatment? It's 30 feet deep. I mean, and that's, I'm asking this as questions, I don't know, right? But that's kind of the economic conversation that I think that's outside.
Right now, we don't even know how bad the orders will be.
Yeah.
But we will.
Yeah.
Because,
But we will, no matter what.
yeah, we will no matter what. Because they're gonna have other shoot, so. I mean, we do take a lot of BOD out of the water right now with our digesters. But from 4 to 5,000 down to 200, so that's a lot.
So what kind of time frame we're looking at for a decision?
Well, I think
Yes,
we're gonna move forward, the design of secondary treatments a month away. Might as well go ahead, move forward and complete that design.
Yeah.
Move forward with, we're going down the financing path with Whitfield. We do not have to use those funds. So in fact, we don't even get any interest charge until we pull the funds out for the project. So I say we go down that pathway too, and then in the midterm, we start.
Keep looking at numbers.
Yeah, keep running numbers, keep looking at different options. Justin actually sent us a different option too for secondary treatment right before this meeting.
Don't we have do we have a deadline with DEQ to have the 100% design? Isn't that short?
Yeah, we're way ahead of.
Oh, we are.
Yeah, we're way ahead.
That's in September, right?
So there is.
Yeah. There's a September 2025 due date for preliminary design. It does not need to be complete by that date.
Yeah, we're already at 90. We're gonna be at 100 in a month. It'll be nice. So that's that requirement.
Before we sign our paperwork up with him, we are committing to a specific project.
Yeah.
The decision needs to be made prior to that point.
Yeah. All the way to put financing is going in out on it. There was a break in the dam this morning. I was telling you.
It's a bad metaphor.
Huh?
We don't want to install it.
I would like to explore other options, and back to your question, provided this, I'd like to approach it going forward with those and giving us time to look at other options. Starting to lean pretty strongly into that, as long as you can check a few boxes that we take care of as a public agency in Morrow County.
Is it in Joe, in your work or consorts, is odor part of that equation, engineering stuff at all?
Yes.
They talked about odor reduction in buildings, you know, but.
Odor is just what everybody's gonna notice.
Yeah.
There's other biological issues with having deep ponds with untreated water.
Gotcha.
That's the kind of stuff we need to know about.
Yeah, you want to explain some of those?
Well, I'm not the right guy. Well, that's, I was trying to, and I think Consort kind of answered some of the question. What I was trying to distinguish was just how we were using treatment. I think kind of entered as a blanket statement of all these other things that we treated, but the original kind of driver was the nitrogen, right? But when I say that, if I say, well, can we revisit whether it needs to be 7 or 20? I'm not saying anything about whether there's benefits of getting BOD or TSS down to a certain level, right? Those are, they're related because they're gonna have some sort of similar process, but I just was trying to emphasize that where we set those targets, we need to, I think we need to be like, what are we specifically trying to get nitrogen to this level? What's the acceptable BOD level? What's a TSS? And then you can manage your treatment system to hit those. So odor is one of them. Odor is gonna be related to BOD. And if we need to treat that odor and BOD to a certain limit, it might also remove nitrogen and these other things. So I was just, a lot of times we say treatment as a blanket and we don't discriminate or distinguish between each of the individual things.
And that's when we need to start hearing those options for my decision making. Thank you.
So
and I don't mean to be, I want to clarify my earlier comment. Checking boxes is not what I mean. We take cleaning the water seriously and improving the water as we promise. I don't mean to be flip by saying checking boxes, but there's some answers we need in order to accomplish that most effectively for everyone.
Anything else for Jake? I assume that's what you have, Jake?
Yeah, that was pretty much it, the rest of it.
Okay. Any other questions or comments? Anybody on Zoom?
I guess I have a question for you. When do you want another meeting like this?
Any idea what? Some more, I guess, some more detail.
Probably 2 weeks. Well, it sounds like we've got some deadlines, and I don't need to postpone this conversation. I think it's fresh in our minds. There's a lot of information to keep fresh in our mind. So maybe, but don't put too much pressure. I mean, if it's not 2 weeks and it's 3 years, sometimes it's okay. But we're making progress in my decision. So I appreciate that. Every time you meet, certainly it's important.
I think we can be flexible enough about it. Our board anyway. Okay.
Well, want back for another week so that they can prepare. I saw you looking at Joe, so.
Oh,
Let them know that we're expecting something from them.
I think we should, discuss maybe either offline or what we would be preparing. I think what I heard, part of what today was for me at least is just a communication with Consort 2 on what their objectives are. And I think maybe that's in terms of what Consort to figure out. Are we good with the design? Does it meet the flexibility that we just discussed here? If there's something you guys want from us in terms of some of the long-term planning, and that's more, I think there's probably a little bit of an iteration process with DQ2 on what they see as acceptable. There's a lot of other compliance stuff going on. We can talk about today. RIFS that Justin mentioned, and others. So that's not a 2-week thing, but I mean, if you want us to provide like a method or an approach, that's something we could prepare in the next couple of weeks here. So
Would it be acceptable to you know, and I don't know the time, around 2 weeks, I'm not gonna set an arbitrary time, but do we need to, Consort worked on one specific treatment system with a set goal? Is there a different treatment system that we need to look at altogether that would get more of the BOD? I'm not a treatment expert, so I mean, but is there, if the issue is not getting nitrogen out of the water, but the issue is the BOD in the pond, is there a different treatment system that could accomplish that is significantly less complicated or costly?
So it might be beneficial to everybody if we went back and did kind of we didn't just pick this out of thin air, right?
Understood.
We did a very strenuous alternative analysis, figuring out exactly what was the best treatment process for our water, for denitrifying water. Like that was priority number one, had to bring down the stable nitrogen number, whether that was 7 or 4. And this is what was the result of that alternative analysis. Well, it seemed like every other technology we went down the path on ended up being more money or unproven technology, or, I mean, there's a bunch of concepts out there, but show me where someone's gotten it built. And that's the problem.
Understand completely. And that's what I'm wondering is if the goal has shifted a little bit to maximum denitrification to, you know, nitrogen stabilization and BOD removal.
So I think it's worthwhile for the next conversation. We'll go back and we'll bring up some of those additional options that were vetted, and why they were not selected in the process.
I think that's what we wanted to hear, right? That was your comment, was that's what those options.
And I think we could leave it to you and the staff to put a time frame on it. You know, and then we can. You can kind of recap what you've done here. Because if we said, hey, it's gonna be 3 weeks, I mean, we could say that, but is that practical?
Is that analysis already done somewhere? Is it already written? Is it, or is it just in your head and in the file everywhere?
And Mark was here for the ride. There was over a duration of probably 9 months back in 2021 and 2022, starting before that. We looked at sequential batch rate. I mean, we looked at a bunch of different options.
So the analysis has already been done. What, are we just doing it again for?
Just different priorities. There's maybe after now we're working on the table, there's
Like I said, Justin sent me something, I'm not sure what it is, but we'll look into that too.
sure it'll have input.
So just like a simple example of Jake telling me this is something that you guys have done. So like if the farmers, like the current BOD target is 20, right? And I think that's what based on.
For winter application.
Well, right, but I think that's probably what the concept of the park, right? So I guess my question would be like, so if we do a little research on, like, I think Idaho actually has recommendations for BOD loading per acre, and then we say, okay, based on this, it's how many X pounds per day. Confirm with the farmers, like, yeah, this BOD is gonna be more be able to use it, and that changes from 20 up to 500. Maybe just the simple thing is, okay, so now your team with Consort is able to say that results in an OpEx reduction of X million dollars per year because we're only running a roller set. Like, is that something that could be easily answered, or is that like was it, you know, like total reason?
Well, the whole thing is storage, right? So that's the whole reason for the reduction is the winter storage.
Their current levels right now, we don't see any negative crop impacts from that standpoint. So your current BOD levels now we're not seeing a yield drag from that. And so, you know, with that being said.
I think Frederick was saying, you still have to get through BOD to get to nitrogen.
Yeah.
And then the nitrogen is really a question of what we were talking about, which is what is the appropriate amount to apply to the plant?
Of BOD.
Nitrogen.
Yeah.
You have to get the BOD, right? That's the thing.
And you have to get BOD out to store it in a pond. I mean, that's the nitrogen consumption.
Right. So it's not a simple question.
Right.
The question.
Okay, well, keep us apprised. Maybe we'll set a meeting, 2 weeks through.
Yeah. Thank you guys for your time again.
Okay, yeah, thank everybody for the time, Consort. Let's see, it's 12:32, I will adjourn our workshop.